Hello everyone, we are going to start our Pure Maths revision for the Pure Maths paper 1 class exams in this week, and I think tomorrow. And again, we are obviously going to solve this worksheet, that is actually all the questions from the recent question papers. All the 2023 series and 2022 series will be added in this. Okay, so all these recent question papers are compiled in this worksheet, and solving this worksheet will actually clear your concept about simultaneous equations, graphs, quadratic equation, then logs, and binomial theorem, trigonometric equations, and mensuration. Okay, now in pure maths they have a very repetitive pattern. Like in all the questions they will ask you, like that will be a fixed concept, that they will ask you one question from equation graph, one question from integration to calculate the area under the graph, and then one question about the volume of the graph, and then one question about your normal simple factorization theorem, right? And on optional they would also ask you in some questions trigonometric equations or simultaneous equations. These are like not exactly coming up to your every exam paper, but mostly asked in the recent question papers. So solving this entire PDF or entire video will actually help you to revise all the question papers you did for the last few months. Okay, so now again you can get this entire file in my WhatsApp. This is my WhatsApp. Okay, you can inbox me in my WhatsApp to get this file, or you can join our Discord group that will be added in the description box. The link for our Discord group will be added in the description box, so you can join in our Discord group to get these files automatically and also get the notifications automatically whenever I upload a recent, like a new video. All the files related to that video will be automatically added to our Discord link. And this is my email address. For those of you who does not have Discord or WhatsApp, they can also inbox me or email me directly to get this file, but it might take some time because I'm not that much active in my email. But again, within 1 to 2 days you can get the file through email also. Okay, and we are actually starting our new batches from this next month, June, for the AS and A2 classes. For AS classes will actually start from July, because exams will end throughout the June, right? So our AS classes will start in July, and our A2 classes will start from June. So those of you who are interested, you can do a trial class with us. And for again to join the trial classes or to join our regular classes, you can inbox me in my WhatsApp to know further informations about our classes or trial classes. Okay, then let's start. We are going to start with simultaneous equations, and in this simultaneous equation, this is from January 2023, paper 1. In this part it says that giving each value in your solution to 2 decimal places, we need to solve this equation. Okay, for example, over here I will try to keep maybe x over here the subject of the formula, right? Wait 1 minute. Yeah, I can keep x the subject of the formula, or y the subject of the formula. For example, I can already see that over here on the power of y and the second equation, they have 2y present over there, right? What I can do is that I can rearrange the equation with the exponential. So we will start with e to the power of 2y minus x plus 2 is equals to 0, and I can consider these as e to the power of 2y x minus 2, and eventually e would be, or I can consider changing the subject of e to the right hand side, so it will be 2y. Eventually this will be ln, inverse of exponential turns out to be ln, so x minus 2, and eventually y would again be half ln x minus 2. That is the value for your y, that is the equation for your y. After this is the first equation, and this is going to be your second equation, right? Now we can clearly see both the equation are in terms of ln, so it will be easier for us to do our substitution this time. So if I'm going to substitute equation 1 into 2, then it will be ln x plus 3 minus 2y minus 1, 0, and eventually I have ln x plus 3 minus 2. The value for y would actually be now half ln x minus 2 minus 1, 0. Okay, This is how the equation would look like, and then again I can simplify the equations furthermore. So ln x plus 3, this half and 2 will be cancelled out, and now you're left out with minus ln goes to 0, and eventually the minus over here obviously represents division, right? So you have ln x plus 3 x minus 2, and you just let's just take this ln to the right, minus 1 to the right hand side, so it will be positive 1. Eventually if you take this ln to the right hand side again, ln inverse eventually becomes exponential. So now again you have x plus 3 x minus 2 is equals to e to the power of 1, or just e, and from this part again final answer would be x plus 3, this is x plus 3 e to the power of 1. This one gets multiplied with x minus 2, whatever you had on the denominator of the left hand side, and this is x plus 3 e to the power of, let's just write x e to the power of 1 minus 2 e to the power of 1, and you take every x together and every numbers together. So you have x minus x e to the power of 1, and then again minus 3 minus 2 e to the power of 1. Eventually you can take x common, that will be 1 minus e to the power of 1, and then again over here also take minus common, so this becomes 2 e to the power of 1. Finally the value for x would actually be this minus 3 plus 2 e to the power of 1, eventually divided by 1 minus e to the power of 1, right? 1 minus e to the power of 1, and you can just write this directly on a calculator like this way, and this will give you the value for your solution. This would be 1 minus e to the power of 1. Eventually you are getting the value for x as 4.90988. We were asked to keep our answer to 2 decimal places, so we will write 4.91. okay, now after this 4.91 I will zoom out a little bit. Now since I have the value for x, I can input this in a value for y to get the value for obviously y, right? The value for x was 4.91, so I'm just going to substitute that x equals to 4.91 into equation 1. Equation 1 was y half ln, it was x minus 2, so now it will be 4.91 minus 2, and then again write this directly on your calculator, and this will give you the value 1 over 2 ln 4.91 minus 2, and this eventually turns out to be 0.53. So over here the solutions are x and y is 4.91 and 0.53, that is your value. If I zoom out, this is the entire solution for your question 1, or actually question 9 of January 2023 paper 1. Then we'll move on to the next question. For this series, for this part of the video, we're only going to focus on simultaneous equation. So this is again from question 2, May 2023 paper 1R. So one solution of the following simultaneous equation is given, half and q, and where p is an integer, q is a prime number. This is quite important. P is an integer and q is a prime number over here. Find the value of p and the value of q. Okay. For example, if I input the value for half in your first equation, then I can get, in your second equation, right? Yeah, in your second equation, then I can easily get the value for your q. So let's just substitute the value into your second equation to get the value for q. For part A, substitute minus half q into equation 2. I'm considering this as equation 1, this is equation 2. So in that case, now you have 6x square minus xy is equals to 5, which is going to be 6 minus half square minus half y was q over here, is equals to 5, and eventually now you have 6 negative 0.5 square, which is 1.5, and this is plus 0.5 q and 5. You just have to make q the subject of this formula, so 5 minus 1.5 divided by 0.5. So 5 minus 1.5, 5 minus 1.5 by 0.5. This one gives you 7. So the value for q turns out to be 7, which is also a prime number, and we will input this into the first equation to get the value for p. So if the value for q is 7, now I have the already solid solution, negative half and 7. We will again substitute the solution in first equation to get the value for p. So for that part, again I'll write substitute. This time I will not write negative half and q. I already have the value for q, which is 7, into our first equation. So first equation was px plus 9. So you have y px plus 9. Instead of writing y, we'll write 7. This is half x, sorry, half x, right, half p actually, sorry, half p plus 9. And then again the similar concept, you just have to make p the subject. That will be 9 minus 7 over 0.5. And this one turns out to be 9 minus 7, 0.5, which is 4. So the value for p is also an integer number, right? So p turns out to be 4. Then again, this was just the solution for part 1. For part A, where they asked you to calculate the value for the alphabets p and q. In part B, now they wanted the original solutions of the equations. So write the equations in a simplified way without the alphabets. The first equation would be y is equals to 4x plus 9. This is your first equation, and the second equation was the way it was, 6x square xy equals to 5. This is your second equation. I can clearly understand I have to substitute the first equation into the second one. So that will be substitute first into second, which is going to be what, 6x square minus x, 4x plus 9. Instead of writing y, I'll substitute the value for y from equation 1, and eventually this will be 6x square, 4x square minus 9x, minus 9x equals to 5. This is eventually turning into a quadratic equation, 9x minus 5, 0, and this is now 2x square minus x, 10x minus 5, 0, right? And eventually you get 2x, not exactly 2x, you cannot take common 2x over here, so x, 2x plus 1 minus, I can take 5 common, so again 2x plus 1, this entire thing equals to 0, so you have x minus 5, 2x plus 1, 0, and eventually the value for x is 5 and the value for x is half, right? These are the value for your solutions for the first part, values for x. Now as you have two values for x, you're also going to get two values for y. So we will substitute both values for x into the first equation to get two different values for y. So again we'll write substitute values of x into equation 1, which is going to be x equals to 5, which will turn out to be y 4, 5 plus 9, that is 29, and then again when we are going to substitute x equals to half, this will make 4, so this is actually negative half, right? One of the solution was already provided as negative half. This one is supposed to be 7 then. This plus 9, so this is 7, right? So the solutions are 5 and 29, so 5 and 29 and negative half and 7, right? These are the solutions for x and y. If I zoom out, this was on the left hand side, you have the working for part A. On the right hand side, this is the working for your part B. Okay, quite easy. Then we'll move on to the next question. The next question was not entirely about simultaneous equations, but this was about logs, so I thought solving it. It might come across in your exams also, because the type logs question were not actually asked in the recent question papers, so they might ask you this type of questions. Over here, solve the equation, this one, and give your answer to 3 significant figures. Okay, now in this situation, as you can see that log base 4 and log base 2, I mean there are two logs introduced. This is again log x. They does not have same amount of log base in the 3 cases, right? So what you have to do is that you can break down these logs in similar process, okay, in a similar base. So for that part, wait 1 minute. Yeah, over here I can do this like this format. For example, log base 2 is already in the basic format, right? I cannot break log base 2 because that is the smallest number, but I can break log base 4, right? 4 can be broken down into 2. Now over here I'm going to use the division formula. Now over here you had log base log x and log 4. I'm going to consider base 2 for all the cases, right? This is how I broke down the middle term. And then you have log base x2, so I'll take 2 over here, and in the denominator I'm going to get log x, and then again I'm considering taking log base 2 in all the cases. Now what does this indicate? From the next line now I have log base 2 x power 3, this is going to be log base 2 x square, and divided by, this one actually turns out to be 2. How this one turns out to be 2? Because 4 is the square of 2, right? So you can write log base 2 square, you can take that 2 in the front, and log base 2. This one turns out to be 1. According to our formulas for log, whenever the base and number is equal, that entire thing turns out to be 1. So this one over here gets 1. 1 into 2 is eventually 2. So on the base you now have 2. This is 2, and over here you have this one again, this is 1, right? So 3 divided by log base 2x equals to 0. At this part I will take this 3 log base 2 to the left hand side. So now you have 2 log base 2 x power 3, then log base 2 x power square, this entire thing divided by 2, and this is equals to log base 2x. Eventually when you simplify it, for example you take this 3 in the front and you take this 2 in the front, they will be like multiplied whatever you have in front of that log base 2x. So it will be 6 log base 2x plus 2 log base 2x divided by 2, and this is equals to 3 over log base 2x. Eventually if you take 2 common from the numerator, you are going to have 3 log base 2x plus 1 log base 2x divided by 2 and 3 log base 2x. So these 2 and 2 gets cancelled out, and now you are left out with 3 log base 2x plus log base 2x equals to 3 over log base 2x. You can take that log base 2x from the right hand side to the left hand side, and now you have 3 log base 2x and 1 log base 2x. This turns out to be 4 log base 2x, right? So you have log base 2x multiplied with log base 2x, because you took this one to the left hand side. This is equals to 3. So now you have basically 4 log base 2x whole square, right? Because these two things are similar. When similar things are multiplied, obviously you're going to get that number as a square. So now you have log base 2x whole square and 3 over 4. I'm just taking that 4 to the right hand side. Again, if you take that square to the right hand side, this will be 3 over 4 under a root. And eventually, if you take that base to the right hand side directly, so you have x is equals to 2, 3 over 4, everything under a root. And if you calculate this directly again, this will give you the final value for your entire solution. Wait 1 minute, I think over here they were asking about the answers, right? The answers over here indicate this one is actually plus and minus, right? Everything whenever it comes out of a root, it becomes positive and negative. So this is your one value, and the other value would be same thing with the negative power. So if you calculate both the values, 3 over 4, that turns out to be 1.82 according to 3 significant figures, and if you just use negative power, that one turns out to be 0.549. This is 0.549, right? These are your answer over here. So again, if I zoom out, this is the solution. This is how the solution would look like. I hope this was clear for all of you. Then we'll move on to the next question. Then again, we have a simultaneous equation, but this time this is in terms of log. For this part actually, I can see that they have used base 2 and 3, 9 and 2, which I can understand 4 can be broken down in terms of 2, whereas 9 can be broken down in terms of 3. So for this part, I will actually make x the subject of this formula. No, I don't think I can make x the subject of this formula over here, right? Yeah. It would be better if I simplify all of the equations and then start simultaneous and then start substituting them. For example, from the first equation you have 2 log 4x is equals to log base 3 3y square. From this part, obviously I cannot simplify log base 3, but I can simplify log base 4. That will be log 2 log x divided by log 4. I'm going to consider using log base 2, and then log base 3 3y square. Okay, this one turns out to be, now obviously log base 2 4 is 2. I already explained this in the previous part. So you have 2 log 2x divided by 2 and then log 3 3y square. This 2 gets cancelled out and eventually you have log base 2x log base 3 3y square. Okay, now this is your I'm not going to write this in this format. I'll just take all these things to the left hand side. Now this is your first equation. Okay, I've simplified it and kept it in the very simplest format. And your second equation was log base 2x power 3 plus 8 log base 9y is equals to 13. Over here I'm going to break down the log base 9 over here. So I'll just keep out log base 2x power 3 like the way it is, and this one will be 8 log y divided by log 9. This time I'm going to take 3 as a common base over here. Wait 1 minute, I actually need much more space. Is equals to 13. And then again similar concept, log base 3 9 actually turns out to be 2 again, because 9 can be broken down in terms of 3 square, right? So if you have log base 3 3 square, that will obviously be just 2 in that case. So now you have again what? I can just write this as log base 2 x power 3 plus 8 log base 3 y divided by, on the denominator now you have exactly 2 is equals to 13. Obviously this gets cancelled out and you have 4, and eventually the second equation turns out to be log base 2 x power 3 plus 4 log base 3 y is equals to 13, and this is your second equation, right? This is how you have to simplify it, and then now you can either substitute it or eliminate it, but I would suggest no, actually you cannot eliminate from this part. You have to substitute, you have to do substitution for this part, right? So for example over here I will not consider this entirely as equation 1, right? I will consider this one as equation 1. In that case the value for log base 2x turns out to be log base 3y whole square, right? So over here if I just substitute the value for equation 1 into equation 2, so substitute 1 into 2, that will be, I have log base 2 x power 3, right? I'll just I'll just write this as the way x power 3, then 4 log base 3 y equals to 13. I'll just take that 3 in the front, so now you have 3 log base 2 x plus 4 log base 3 y is equals to 13. Now in this case 3 log base 2 y turns out to be log base 3 3y whole square plus 4 log base 3y is equals to 13, and then again over here you're going to get what, 3 log base 3 y square plus 4 log base 3y is equals to 13. Now over here what I can clearly see is that they are not of like equal power, so I cannot add them together. We cannot do 3 plus 4 7 log base 3y, because over here you have 3y, over here you have just y, and again on that first part you have 3y square, right, not just 1y. That is actually a problem. 1 minute. Wait, can I take that 3y square over there, right? This is not a power of whole square in that case previously, right? It was just 3y square in that case. Over here we actually have to break down that first equation furthermore in order to simplify it simplify it easily. For example, over here in this case I can break down your value for 3y. It is in multiplied format, right? 3 multiplied with y square. So I can break this down as log base 2x log base 3 plus log base 3y square, which turns out to be 1 over here. So eventually now you have the value for log base 2x as 1 plus 2 log base 3y. Now we can easily simplify it, and then again let's do this working. We just take this 3 to the front, so 3 log base 2x plus 4 log base 3y is equals to 13. This is also equation 2 now. And then we can easily simplify it now. So now we will substitute the values. That substitute 1 into 2. This is going to be equation 1. And now again over here we will start with the equation 2. So log base 2x, 3 log base 2x plus 4 log base 3y equals to 13. And now we can write 3, 1 plus 2 log base 3y plus 4 log base 3y is equals to 13. Similarly, now you have 3 plus 6 log base 3y plus 4 log base 3y is equals to 13. Now you have what? 4 plus 3 is, sorry, 6 plus 4 is 10. So you can write 10 log base 3y. If you take this 3 to the right hand side, obviously it will be eliminated with that 13. So this gives you 10 again, and this 10 and this 10 can be cancelled out, and now you have log base 3y equals to 1, which eventually can be written as y is equals to 3 power 1 or just 3. So you get the value for y as 3. Now using the value for y as 3, we can substitute this into any of the equation to give you the value for y, for the value for x again. For the last part, for the value for x, I'm going to substitute this into the equation 1. So we're going to write substitute y equals to 3 into equation 1, which turns out to be log base 2x 1 plus 2 log base 3. This one is 1 again, right? Log base 3 is 1. So now you have log base 2x 1 plus 2, that is 3, and now eventually x is actually 2 to the power of 3, that is 8. So the values for x is 8 and y is 3. So this is the solution for this simultaneous equation. Quite tricky because you have to work out all the way from log to substitute the eliminations, like substitute the equations and then find the value for x and y. Okay, then after this we'll move on to the next part. This was all for the simultaneous equations. We'll now move on to your square root equations or cosine sine rule equations used in pure maths. For example, over here in this question, this is from November 2023. For this part, we have figure 1 shown in the triangle ABC, where it is written that ABC is 90 degree over here, and the length for AB is 2 plus 4 root 5, BC is A plus B root 5, and where A and B are integers. The area of the triangle has been provided to you, and you have to use this to find the value for A and B. Over here, without using a calculator, they indicate that you have to show all your working for this process. Okay, so for this case, since I have been provided with area, so I have to work with area, right? Other than that, they haven't provided me anything other than that information. So obviously I have to find out my value for alphabets A and B by using the concepts for the area of this right angle triangle, which I can clearly understand will be half into base into height, right? So over here now I have the area of this triangle as 34 plus 11 root 5, and this is equivalent to half. Height was 2 plus 4 root 5. This multiplied to a plus b root 5. Okay. Now from this 2 plus 4 root 5, if I can take 2 common, this will be 1 plus 2 root 5 multiplied to a plus b root 5. This is equals to 34 11 root 5. Obviously this one gets cancelled out, and now you have left out with 1 plus 2 root 5 a plus root 5 a plus b root 5, which obviously will be what, 1 plus a plus 2 root 5 will be a plus b root 5, and then again 2 root 5 plus into a plus b root 5 will be plus 2a root 5, and then again 2b. If you multiply root 5 with root 5, you are going to end up with just 5, right? So this one turns out to be 5 with 2 eventually becomes 10b, right? This part is equivalent to 34 plus 11 root 5. We have to use equality over here. For example, in this part, for that constant like 34 over here, this will be a plus 10b, and this will be 2a plus b root 5. This is equivalent to 34 plus 11 root 5. Now over here we can understand this part is equivalent to 34, and then again this part is equivalent to 11. So I just have to use comparison over here to find out the values for a and b. So we'll start comparing. If you start comparing the constant, which is basically a plus 10b and equivalent to 34, this turns out to be a equals to 34 minus 10b. A equals to 34 minus 10b, right? This is equation 1, and then again if you start to compare the coefficients for root 5, this is again 2a plus b equals to 11. So this is equation 2. I will obviously substitute 1 into 2. So I'll start the working over here. Substitute equation 1 into 2. Now you have 2a plus b equals to 11. Instead of writing a, I can write 34 minus 10b plus b equals to 11. So now you have 34 with 2 is what? 68, right? 68 minus 20b plus b equals to 11. So you can just take 68 minus 11. This one turns out to be 19b, right? So eventually b is 68 minus 11 divided by 19 is actually 3. Okay, this is actually 60, this is 57 over 19, this turns out to be 3. So the value for b is 3, and if you substitute the value for b into your equation, into any of the equation, maybe in equation 1, okay. So substitute b, b equals to 3 into equation 1, then you have a equals to 34 minus 10, 3, this turns out to be 30, and eventually the value for a would be 4. So the value for a is 4 and b is 3, right? So this is the solution then. Okay, so with this, this question comes to an end. We'll move on to the next question. Similar process, we now have been provided with a rectangle where the lengths are provided of AB and BC, right? Yeah, AB and BC is provided, and again the area is provided, right? We have to find out the value for A and B. Similar process to the one we did in the previous question. This one is from May 2023, 1 PR. So let's start with this. Again, the area for your rectangle is what? Length into breadth, right? Just length into breadth. So for this case, we are again going to start with the basic concept of area that has been provided to you as 10 plus root 2, which is obviously equivalent to that 4 minus root 2 multiplied to A plus B root 2 is equals to 10 plus root 2. We're obviously going to do comparison over here also. So 4A plus 4B root 2 and then minus A root 2. This turns out to be minus 2B equals to 10 plus root 2. Right, similarly we'll just take the constants together, that 4A minus 2B, and then for root 2 you have 4B minus A root 2. This turns out to be 10 plus, if we have just root 2, then obviously you have 1 root 2 over here, right, which clearly indicates that this is your comparison with 4A root 2, 4BA, and then 10 over here is equivalent to 4A minus 2B. Similarly, we are now going to start comparison for this part. So compare, you have 4A minus 2B equivalent to 10, and then again you have 4B minus A equivalent to 1. From this part I can take A common, so this one becomes 4A minus 1. This is equation 1 and I am considering this as equation 2. So for this part again I will substitute 1 into 2. Equation 2 was 4B minus 2A, 4A minus 2B equivalent to 10, and A is 4B minus 1. So instead of writing 4A, I will now write 4 multiplied with 4B minus 1. So 4B minus 1 minus 2B 10, and now you have 16B minus 4 2B 10, which is 14B over here. 14B, if you take this 4 to the right hand side, this one also becomes 14. So eventually the value for B turns out to be 1. So since the value for B is 1, we will substitute this into your first equation to get the value for A. Your first equation was A equals to 4B minus 1. So we'll substitute B equals to 1 into equation 1, which is going to be A equals to 4B minus 1. So which is A 4 1 minus 1, and that is 3. Right, so this is the value for your A and B using the substitution method. So yeah, this is it for question 1 of May 2023 1 PR. After this we'll move on to your next question. This is again a similar concept, but I think they're using cosine rule over here. This is for May 2023 1 PR question 3. Over here they have provided you with an angle of 100 degrees and then lengths of 10 and 8 centimeters, and opposite to that angle you have x centimeters. So the values for AB is 10, AC is 8, BC is x, and angle BAC is 100 degrees. We need to calculate the value for x. Obviously we are going to use cosine formula, right? Cosine rule over here. That is easy. So for part A, for cosine rule, let's make a note for this. We have a empty page, right? Okay, let's just understand the cosine rule here. If you want to find out the angle for a cosine rule, right, angle is always like angle A. This is going to be cos inverse B square minus C square, plus minus A square divided by 2BC. And then again, if you want to find out angle B, similar process, only in this case now you have B square in the minus format divided by 2AC. Okay, lastly for angle C, this is going to be cos inverse A square plus B square minus C square divided by 2AB. right? This is the angular formula. And then again, if you want to find out the length of an angle, length of a triangle whose angle has been provided, for example in this maths, for side A, this is going to be b square plus c square minus 2bc cos angle A, and everything will be under a root. Similarly for B, this is going to be a square plus c square minus 2ac cos angle B, right? Similarly under a root. And then again lastly for C, this is going to be a square plus b square minus 2ab cos angle C, and everything under a root, right? This is the formula for your cosine rule. So I would suggest memorize this for tomorrow's exam. Very important. They would obviously ask you at least one question from this concept. So quite important. This is your cosine rule. This is like a mini notes. So I would suggest memorizing these formula for length and for your angular calculations. Then again we'll move on. Now we are actually trying to find out the value for BC, which was x centimeters. So x would actually be what? 10 square plus 8 square minus 2, 10, 8 cos angle C was 100 degrees. And if you take this like on your calculator directly, this will give you the value for your length x. So 10 square plus 8 square minus 2 into 10 into 8 into cos 100, cos 100. This one turns out to be 13.8 as a value for your A. So the value for A is 13.8, and this is the working, right? No other calculations are needed. This is the final value for your length of x or BC. After that again they want to find the degrees to one decimal place for the size ABC and ACB. Okay, for these angles they want to find out the angle value. So for ABC I can easily use what? Cosine rule over here. Sine rule over here. Again for sine rule I do not have much space. 1 minute. I'll try to find out a space in the previous pages maybe. Yeah, I'll just keep the sine rule over here. Okay. For the sine rule again, you are going to be introduced with a non-right angle triangle. This is a non-right angle triangle, and over here, if this is your side A, B, C, then this one is small a, this one is small b, this one is small c. In that case, if you have to find out the angle, right, in that case you have to have the corresponding other side of the side. Like for example, if you are trying to find out this angle, then this value should be given, then another angle and its corresponding side should be given. That means angle C with side C, angle A with side A, any either of them should be given, because in sine rule what happens, they all have the same ratio, that sine angle B divided by side B, then sine angle A or C divided by side C, and sine angle A divided by side A. They all have the same ratio. So whenever you are going to find out any angle, you just have to identify that if any other angle and its corresponding side has been provided to you or not. If they are provided, then you can use their formulas. So this is your sine rule format. Okay, so we'll move on then again, and obviously as I'm writing like noting down different formulas for these questions, I would also suggest you guys to do that out as well. So we will find out the value for your angle B, which I can clearly find out using the angle A and the opposite side of A, which was x now, right? I already have the value for x, so obviously I can use that. So sine angle ABC, this will be equals to, like, divided by 8, the opposite side for ABC was 8, right? And then it will be sine 100 divided by this 13.8 we calculated in the previous part. So we just directly make ABC the subject. This one turns out to be 8 multiplied with sine 100 divided by 13.8, and everything will be inside a sine inverse function, because when you take this sine to the right hand side, obviously it will become sine inverse. So you have sine inverse 8 multiplied with sine 100 divided by 13.8, which turns out to be 34.8 degrees. We were supposed to keep our answer in one decimal place, so this is your part 1. In part 2, they ask you to calculate the value for the other triangle, which you can directly find out using a sine rule, or you can use the sum of a triangle in that case. I would suggest use the sum of a triangle, it's just easier to work with in that case. So for part 2, in order to find out angle ACB, what you have to do is that you just have to subtract the other two angles from the sum of a triangle, which is 180 degree. So this one turns out to give you 180, 100, 34.8. This is 45.2 degree. Okay, this is the solution for your part B. Finally, it says that the bisector of the angle ABC meets AC at point M. Find out the area of this BMC. Okay, now always remember, bisector, when it meets to the other side, it will always be perpendicular to that point. So this one, the angle ABC bisector, right? Angle ABC bisector means this line will actually divide the angle ABC into two equal parts, which makes this 90 degree. Okay, that means this angle red line over here is intersecting the point at 90 degrees. So this is your point M over here. And now they want to find out what the area in centimeters square of the triangle BMC. Okay, for BMC, that means now they're only interested for this triangle, this portion of the triangle. Okay, 1 minute. Now over here I can understand one thing is I can find out the angle over here, that will be what, half of that 34.8 degree, right? This one will be 34.8 degree. 34.8 divided by 2, so it's 34.8 divided by 2, this turns out to be 17.4 degree, right? The value for the angle is provided 17.4 degree, but we need to find out the area. Maybe I have to find out another angle from this part and then calculate the area over here. Other than that, I don't think I can do any other calculations. Now over here I actually cannot know, sorry, I was actually wrong, that the bisector of ABC meets AC at point M. We cannot think of these as 90 degree. Okay, this is not a fixed 90 degree. We cannot think that as a 90 degree. This is an angle but not 90 degree. So in that case, now this is not an entire 90 degree. This entire thing makes again a scalene triangle, right? A non-isosceles, non-right angle triangle, a scalene triangle. Okay, let's just work with this BMC in a separate diagram. Let's just work with this part C over here. This is roughly the diagram for BMC. This was angle MBC is going to be 34.8 degrees divided by 2, which is going to be 17.4 degrees. Okay, now the value for this is 17.4. BC is going to be restored as 13.8 centimeters. MC would again have changed, right? It will not be obviously 8 centimeters. It will not also be 4 centimeters, right? Over here I do not know where the value for MC would be, but the value for C, angle BCM, will turn out to be like the same value, 45.2 degree. Now over here what I can do is that I need to find out the value for this side. Okay, so in order to find out the value for this side, we need the value for this angle, which is angle BMC. For that BMC, obviously I'm going to use the same concept, 180 minus 45.2 minus 17.4. This is going to be 180 minus 45.2, 17.4 this turns out to be 117.4 degree. So this one is 117.4, and using cosine rule I can easily find out the value for BM, right? Because BM, the angle for C is already provided, 45.2. So for this case, now I have sine 45.2 degree, this is divided by BM, is equals to sine 7.4 degree. This is again equals to 13.8. So from this portions, if I make BM the subject, this will be just 13.8 multiplied with sine 45.2 degrees over sine 117.4 degrees. And eventually now you have values of 13.8 into sine 45.2 divided by sine 1117.4 degrees. Now you have 11.03 centimeter. The length for that BM is 11.03 approximately. Now you can use the formula half into AB sine theta, because you have the value for theta, you have this value for B, you have this value for A, right? So obviously you can use the formula half AB sine theta to get the area of this triangle ABC. So triangle, not ABC, BMC, my mistake. BMC is going to be half sine theta was for 17.4 over here. This is multiplied to 11.03 with 13.8. This one is 22.8 centimeters square, right? That is the area for your triangle over here. After this, I think this is the end for your question, right? Yeah, this is the end for your question C, right? No other working has to be done. So yeah, that is it. We will now move on to your next question, that is from Jan 2021P. You have to represent this fraction that can be written as b root 3 minus 9, where again a and b are integers, and you have to find out the value for a and b. I can clearly understand that if this fraction can be written as this format of b root 3 minus 9, that means they are equal to each other, right? So I'll start writing the equation as they are equal to each other. 48 root 3 plus 1 is equals to b root 3 minus 9. Over here, my main motive is to be simplify the right hand side, sorry, left hand side, because I cannot simplify the right hand side. So in that case, yeah, I mean, I'll just take this denominator to the right hand side. So now we'll have a minus 48 can be broken down. 48 is 4 root 3. Okay, 40 is 4 root 3. So this is 4 root 3, and this one turns out to be b root 3 minus 9 and root 3 plus 1. So now you have a minus 4 root 3, and then b root 3 into 3 is what? 3b. b root 3 into 1 is b root 3. 9 into root 3 is just 9 root 3 minus 9. So this is a minus 4 root 3, and then 3b minus 9, and then you have b minus 9 root 3. From this part I can clearly understand that a is equivalent to 3b minus 9, and this 4 root 3, or 4 actually 4 over here, is equivalent to b minus 9. So I'll obviously start comparing with b, comparing with root 3 equations, root 3 coefficients. So if I compare with root 3, now you have minus 4 equals to b minus 9. Eventually it will be b equals to 9 minus 4. Answer would be 5. So the value for b is 5. Using the value for b to be 5, we can compare the constants together. For the constants, now you have a equals to 3b minus 9. So a would be 3, 5 minus 9, which is 15. 15 minus 9 is 6. So the value for a is 6 now. This is how we are going to compare the values for a and b, calculate the values for a and b. So this is it. We'll move on to the next question. Again a similar process, June 22, where the lengths are given x plus 4 and x, and the perimeter in rectangle is p and a respectively. We need to find in terms of x an expression for p and a, which we can clearly understand. For p, perimeter, this is going to be what? Twice length, twice breadth, right? This is your length, this is your breadth. So it will be 2 x plus 4 plus 2 breadth was just x. This one turns out to be 2x plus 8 plus 2x, so basically 4x plus 8. That is the expression for your perimeter for this rectangle. Similarly, we have to find out the area, that is length into breadth. So for area, which is going to be x plus 4 with x, so eventually area is x square plus 4x, right? Yeah, this is it. Now after this, they have said that the perimeter of the rectangle has to be less than 30 meters. The area of the triangle has to be greater than 12 meters. Find the set of values for x. Okay, they have two expressions now. Perimeter has to be less than 30 and area has to be greater than 12. Okay, so we are going to use this data and create an answer or create equations. For perimeter now, that is 4x plus 8. This has to be less than 30, and area now, this is x square plus 4x less than 12. Right, so for example, from the previous part, from the first equation, I can easily get the value for x over here and for the second equation. So start with first equation. From first equation, that was of perimeter, which was 4x plus 8 less than 12, so less than 30, I think, right? Yeah, less than 30. I'll try to make the value for x. Like, I have to find out the suitable range that is possible for both the equations. Okay, so in that case, this one turns out to be 4x, 30 minus 8 turns out to be 22. So this is 22. Eventually the x is 22 over 4 less than 22 over 4. So 30 minus 8 over 4, this one is 5.5. So from this first equation, we get the range to be 5.5, less than 5.5. Okay, and then again after that, from the second equation, which was for the area, x square plus 4x, it was less than 12. So it will be x square plus 4x minus 12 less than 0, which turns out to be, like, if you do the middle term, do not skip the middle term. I am just skipping it because I want to save time. Now if you do not skip the middle term, the values for x would be 6 and minus 2. The critical point for x over here is 6 and 2 and minus 6 actually. Now this is for a quadratic equation, right? For quadratic equation, positive quadratic equation, for less than 0, this is how the graph would be. This is 2, this is minus 6. They are asking you to find out the range for this portion of the area. So range for just equation 2 would be x should be less than 2 and x should be greater than minus 6. This is the range. And now I have to find out a possible common range for both the inequalities. So always in this kind of situations, I draw a straight line. Okay, in that case, if your value for x should be greater than 2, 2, 3, 4, 5, 6, 1, right? This is the case. From the first inequality, it turns out to be less than 5.5, right? Over here, this is approximately 5.5. And from your next equation, this is exactly in between 2 and 6. We can clearly understand that over here, the common frequencies or common values for inequality over here is between 2 and 5.5, right? If I highlight the cases over here, the values that are common in between this is 2 to 5.5, like this portion and up to this portion, from 2 to 5.5. That means over here your final inequality that is suitable, that actually goes for both the inequalities, is between x has to be less than 5.5 and x has to be greater than 2. This is your final range, this is your final answer. Okay, with this our question ends. This was your question for June 22 1 PR. We'll move on to the next question, June 22 1 PR question 6. Similarly, given that this can be written in the format of 11 plus 5 root 5, obviously we can understand, we just have to use similarity, and then we just have to simplify these equations and get the value. So for part A, that we can easily calculate that. Equations was a plus root 5 divided by root 5 minus 2 11 plus 5 root 5, which is going to be a plus root 5, then root 5 minus 2 11 plus 5 root 5. So again simplify it, a plus root 5, and now you have 11 root 5. 5 into root 5, this turns out to be 25, because root 5 is just 5, then again further multiplication of 5 gives you 25, and minus 22, then minus 10 root 5. Now eventually what happens, a plus root 5, 10 root 5 and 11 root 5, this one turns out to be 1 root 5, and 25 minus 22, this is 3 minus root 5. We can clearly understand, so 3 plus root 5. Clearly understand that from this part the value for a would be 3, right, because this one cancels out. The value for a is 3 then. Okay. Now using this, it says that there is a triangle PQR such that PR is x plus 3, QR is x, angle QPR is 30 degree, and QPR and QPQR, right, these are the angles. We need to show that the value for x is like in this format. Okay, let's just draw a triangle for this case. It was stated that PR is x plus 3, QR is x centimeters, QPR is 30 degrees, and PQR is 45 degrees. We can clearly understand we have to use sine rule, right, because the angle and the corresponding sides are provided. So obviously you have to use sine rule and then simplify it. Let's just work with the part B from this portion. Wait, let me see if this was part B, right, this is part B. Okay, in that case for part B, now I'm going to start with what, sine 45 over x plus 3, this is equals to sine 30 degrees over x. Sine 45 and 30 have their own corresponding values. So sine 45 is root 2 by 2 divided by x plus 3, and sine 30 is half. So this is half x. I can half x can be written as what, 1 by 2x, right, because on the numerator you have half. So 1 by 2x, I can just take this, like cross multiply over here, root 2 by 2 multiplied with 2x, and then x plus 3 on the right hand side will just get multiplied with 1. So this 2 and 2 cancels out. You have root 2x, x plus 3. Just take all the x's together. So you have root 2x minus x 3, and if you take x common, this will be root 2 minus 1 3. So if you take this root 2 minus 1 3 to the left hand side, so to the right hand side, it will be divided with this 3. And obviously we cannot keep root in the denominator, we have to rationalize this now. So root 2 plus 1, root 2 plus 1. So now you have 3 root 2 plus 3, and root 2 plus root 2 is just 2, and this is going to be minus 1. So 2 minus 1, this is just 1. So final answer is root 3 plus 3. So 3 root 3 plus 3 root 2 plus 3. On the denominator, the 1 will not be that much significant. Okay, this is the final answer, and you would also have to just show you the value for x is in this format. Okay, let me go back. It was 3 plus 3 root 2, so I will just write that 3 in front, and this is the back. Okay, now after this the value for x has been calculated. Now it says that given that sine 105 is this value and the area of the triangle PQR is angle A. Okay, 105, 180, 45 and 30. Right, the other angle, the angle R was 105. Okay, and they have provided you with the value for angle R. We need to find the exact value for A. This is A, where PQRs are integers. Okay, from this triangle again, I will just use a straight line to divide the portions. Okay, now over here from this triangle again, we now have the value for this angle. This theta was 105. Okay, the value for this theta, or basically sine theta, I mean theta over here or angle R over here is obviously going to be 105, because 180 minus 45 minus 30 turns out to be 105. This was giving you 105. So for this 105 degrees, now I can use the area for this triangle, turns out to be half AB sine theta, right, where what AB was 3 plus 3 root 2, because value for x was this. So this will actually be half AB is 3 plus 3 root 2, then again multiplied with 3 plus 3 root 2, this is x, it was further added with 3, and then the value for sine theta was already given. This was 6 root 2, so you see root 6 root 2 over 4, so this is root 6 root 2 over 4, which now will be 1 over half, inside the brackets 3 root 2, and this one will be what, 6 plus 3 root 2 root 6 plus root 2 divided by 4. Obviously this 4 and 8 on the denominator will be multiplied and eventually create 8, and in the numerator now you have 3 root 2, 6 root 3, right? If you multiply these two together, 3 into 6 is 18, 3 into this will be 9 root 2, this is 18 root 2, and then 3 root 2, 3 root 2 just turns out to be 9 into 2 is 18. Okay, this entire thing multiplies with root 6 plus root 2 and eventually divides with 8. Finally over here in the numerator you have 18 plus 18 is 36, plus 9 and 18 is 27, right? 27 root 2 eventually multiplied with root 6 and root 2 divided by 8. We cannot simplify anything, so we have to further multiply, so that will be 36 root 6 and 36 root 2. 27 root 2 with root 6 gives you 54 root 3. Wait 1 minute, 6 into 2 is 12. Yeah, 54 root 3 and eventually 18 root 2 into just root 2 should give you 36 again, divided by 8. Now I'm quite sure the values for on your area in the format of P, Q, R, S, T were not exactly alphabets. Let's just 1 minute. I will just calculate the value. Yeah, 9 over 8, P root 6, Q root 2, R root 3 and S, right? We are in the correct format then. From this part again, I can take on the from the numerator, I can now take 9 common. So if I take 9 common from the numerator, it will be 4 root 6, 36, right? Then 4 root 2, then 6 root 3, this will be 6 again, sorry, this will be 36, right? 36 is going to be 4, right? 1 minute. wait, sorry, 1 minute, I made a mistake. 27 into 2 is 54. This is 54. So yeah, this is again going to be 54. So this will be 6 again, and divided by 8. They have written this exact thing, just take they wrote the fraction in front. So you have 4 6 root 6, 4 root 2, 6 root 3 plus 6. So this is the final answer. Okay, so this is it. We are going to move on to the next maths. I hope it was clear for all of you. Over here, again similar format. This portion can be written in the format of a plus root b. So 2 root 3 minus 4, 3 root 3 plus 5 equals to a plus b root 3. So it will be 2 root 3 minus 4, 3 root 3 plus 5 and a plus b root 3, which is going to be 2 root 3 minus 4. 3 root 3 into a is 3a root 3, and this is going to be 3 into b. Root 3 into root 3 is just 3, so 9b, 5a, and lastly you have 5b root 3. Finally you have 2 root 3 minus 4. You just take all the alphabets together and root 3 components together. So you have 9b plus 5a, and then 3a plus 5b root 3. Obviously by comparing, you get the values for a and b. That is 9b plus 5a equals to 2 root 3, which makes, I'll just keep the answer like this. And then again for the next portion you have 3a plus 5b. Wait, made a mistake, sorry. For the constants over here, this is going to be the minus 4. This is going to be equivalent to minus 4, and for root 3, this is going to be 3a plus 5b equals to 2. Right, now you can eliminate or substitute. I will use substitution over here again. So a is what? Minus 4 minus 9b divided by 5. Wait, this one turns out to be extremely difficult. 1 minute. Not difficult, but a little bit lengthy in that case. I think I can use elimination over here easily for the easiness of my working. Over here this is 5 multiplied and this is 3. So now you have 27b, 15a minus 12, and this is again 25b, 15a, 10. So when you are going to eliminate the values over here, 15 gets cancelled out, 27 minus 25 is 2b, and this one turns out to be 22. So the value for b turns out to be negative 11. If the value for b is 11, so we'll substitute the value for 11, like b, into any of the equation. I'll substitute into equation 1. So if you substitute that into equation 1, the value for a turns out to be 2 minus 5 minus 11 divided by 3. Right, over here I substituted the value. So 2 minus 5 minus 11 divided by 3, this is 19. So the value for a turns out to be 19. These are the integer values. So we are done with yet another question, so we'll move on. Right, it was already shown that this equation can be written in the format of a plus b root 3. So we will finally write it down as 19 minus 11 root 3. Right, this is how the equation would then be. Okay, then this was it. Over here a similar cosine sine rule. Angle ABC, these are the lengths. Always draw a triangle for this kind of cases when they have not provided with you a diagram. So ABC, length AB was 10, BC was 9, BAC is 50 degrees, and BCA is x degrees. Obviously, we're going to use cosine rule over here. It is going to be sine x divided by 10 is equals to sine 50 divided by 9. From all these parts, if you just make x the subject, this will be 10 multiplied with sine 50 degrees divided by 9, and this entire thing will be inside a sine inverse function, which turns out to be sine inverse 10 multiplied with sine 50 divided by 9, 58.3 degrees, right? 338, so we can consider 58.3 degrees as the value for this. As they asked to keep your answer in one decimal place, right? Problem is they asked you to calculate the values. That means over here you have to also calculate the second value. This was the first value. For sine, the second value calculation is 180 minus 58.3 degrees, which turns out to be, this first value was 58.3 degrees and the second value was 121.7 degrees. Okay, that is the value for your question 2. One thing to remember, whenever they want you to find out the values for sine rule, values for cosine rule, you have to find out the second, third value, right? Over here, values means we only consider the first two values, the other two values are not possible, because the third value over here is supposed to be 360 minus first value. For the 360 minus first value, 360 minus 58.3, this turns out to be 310 degree. On your calculator, any angle cannot be greater than 180, right, or equals to 180. So obviously the third value is impossible to fit in this triangle. So that's why we're never going to calculate the third value over here. Another thing, we can understand how to calculate the first value, second value, third value for cos, sine, tan. So you just have to understand these format. Okay, I'll just use this formula over here. So this is the box I was trying to draw. Now we will find out that how can I find out the second value, third value, fifth, sixth, seventh, eighth, whatever value for sine, cos, tan. Okay, so this is for the sine, this is for tan, and this is for cos, and the first one that you get from your calculator, that is your first value. Okay, so first value is always from your calculator for all the values. Okay, this is from calculator. For sine, cos, tan, this is the same procedure. The first value is always the value that gives from your calculator. Okay, so this is from calculator, and the last one for cos also, this is going to be from calculator. Okay, now the second value over here turns out to be, different sections have different formulas. So second value, wait 1 minute, I should write this is a second value, third value, fourth value, then again fifth value, sixth value, seventh value, and eighth value. Okay, now for the second value over here, for sine you have to subtract the first value from your calculator. Okay, first value, that will give you your second value for sine. For tan, you have to add the first value with your 180 degree. So first value has to be added with 180. For cos again, for the second value, this will be 360 minus first value. Okay, and again if you have to find out the values in terms of pi, then it will be pi minus first value, pi plus first value, 2 pi minus first value, right? And then third value over here is going to be 360 minus first value from this part. Next one, you just, the entire pattern is same. The next one will be, for the fourth value, it will be 360 minus whatever you got from this part, that was the second value. Okay, and then again 360 minus third value, and lastly over here it will be 360 minus fourth value. You can clearly understand the pattern, right, that after second value the process is same. 360 minus first, 360 minus second, 360 minus third, 360 minus fourth, and then 360 minus fifth for the seventh value, and then 360 minus sixth for the eighth value. Right, this is the process for sine. Then again for tan also a similar process will be over here. It should be that again similar cases that, wait 1 minute, this is actually plus, sorry, made a mistake. See, 360 plus sorry, this is 360 plus first value, second value, third value, fourth value. Similar for tan again, similar process. For tan again also you have to find out the value as 360 plus first value, 360 plus second value, 360 plus third value. So this is again similar for this part. And lastly for cos also they have the similar process, 360 plus first value, 360 plus second value, 360 plus third value again. So from third value to eighth value, or then eventually it, as you go along the more values, maybe 9th, 10th, 12th, 11th, they will all have the similar pattern. But for the first two values they have different patterns. Only first value has the value calculated from your calculator, and second value is these cases. Okay, now this is quite a very important notes to how to calculate the different angles from our triangle, so very important. Okay, now we'll move on to the next part. Now we're going to start with binomial expansions. Okay, so binomial expansion can be calculated using the factorial theorem, or then can be calculated using the NCR format. Okay, and again with addition with binomial theorem, they have these approximations also added. We have to find where you have to find out the values for x or unknown variable. Now over here they have provided you with an expression that given that 2 plus 3x to the power of -1. Always remember that whenever the expansion has a negative power, then you cannot use your value for your NCR. Okay, then you have to use the value for your factorial theorem. So if the power over here is negative or fraction, you have to use factorial theorem. But if the power is whole number, integer number, positive integer number, then you can use NCR format. Okay, so there is also one notes for this cases for binomial situations, that is if power of the expansion is either negative or fractions, right, then you have to use the factorial theorem. So for this factorial theorem now, this is the factorial theorem, a plus b power n, which is going to be what, a power n plus n b power 1 divided by, sorry, 1 minute, made a mistake. This is going to be a n minus 1 b divided by 1 factorial, right? And then again for the next term you have a, so not a, you have n minus 1 a power n minus 2 b power 2 divided by 2 factorial, plus you have n minus 1 n minus 2 a power n minus 3 b power 3 divided by 3 factorial. Then again n minus 1 n minus 2 n minus 3 a power n minus 4 b power 4 divided by 4 factorial, right? This will again continue for the factorial format. And then again if the power is a positive whole number or integer, okay, in that case the formula should be a plus b power n, where the format is a power n plus NCR, then a power n minus r b power r, right? This is a format. Whatever the value for r is, that will be added in the power of a and b. That is the format. Okay, now this is again a formula for your binomial theorem, so I will just highlight this. Okay, this is again our notes, and this is for binomial theorem. Okay, after this we'll move on to this question. We have to expand this entire binomial theorem in the format p1 plus qx, where p and q are constants, and you need to find out the value for q in this case. Okay, for the first part actually you do not need to find out the value for, I mean, what, 1 minute, yeah, I mean over here you do not need to actually expand it using binomial theorem. You can just take common from this part. For example, 2 plus 3x to the power of minus 2, right? This is your first part, first equation. 2 plus 3x to the power of -1. This has to be written in the form of p1 plus qx to the power of -1. what I can do over here is that I can take two common out of this equation. So first one becomes 1 and 3 becomes 3 over 2x, and now this entire thing, both of the things, 2 outside the bracket and inside the bracket, all of them has a power of negative 1. So if all of things have a power of negative 1, I can write 2 power negative 1 and 1 plus 3 over 2x to the power of negative 1. 2 power negative 1 what will be half, and then 1 plus 3 over 2x power negative 1. This turns out to be the value for p to be half and the value for q to be 3 over 2. So this is the expansion. After that, for part B, now they want to expand this in ascending powers of x up to and including the term x power 3 and expressing each coefficient as an exact fraction in its simplest terms. Okay, so now we'll do the factorial theorem. Now over here for the factorial theorem, obviously we had this 3 power x to the power of negative 1, but it becomes extremely easier when you take the first term to be 1. So it would be better if you take that the format the one we calculated in the previous part. So 1 plus 3 over 2 x to the power of negative 1. So now you just are going to expand the entire expression inside the bracket, and the entire expression will be multiplied with half. So first term over here is going to be what? 1 to the power of negative 1 plus, then it will be minus 1 to the power of minus 1 doesn't make any sense because 1 to the power of any value would be always 1. So I can now directly write 3 over 2 x divided by, sorry, this is 2 factorial. I think I made a mistake for your first part, right? Yeah, this is actually 2, 3, 4, 5. Sorry. Oh, wait, 1. No, I'm actually correct. 2, 1, 2, 3, 4. Okay. Now over here, we'll do the same case. That this is your 1 factorial. I mean 1 factorial is just 1. No one actually writes 1 factorial, but let's just keep it like this. Minus 1, minus 1, minus 1, and then 3 by 2x square divided by 2 factorial, right? And then again after that you have minus 1, minus 1, minus 1. Wait, it will not have enough space for the last term in the same line, so I'll write the last term over here. Minus 1, minus 1, minus 1, minus 1, minus 2, and 3 over 2 x power 3 divided by third factorial. Obviously it will continue, so we'll indicate the continuation with this plus and dot sign, and this entire thing will be multiplied with what? Half, right? Because you have half in front of that entire expansion. So you're going to have half inside the brackets. Now you have 1. This one turns out to be minus 3 by 2x. The second term over here turns out to be 9 by 4x square, positive 9 by 4x square, and the next one turns out to be 27 by 8x power 3 plus dot. And then again everything has to be multiplied with half. Finally you get half. Then you have minus 3 by 4x plus 9 over 16x square plus 27 over 16x power 3 plus dot. One thing, this will be negative over here. Okay, right. That is it over here. Other than that, no other calculations are needed. We have expanded and kept every fraction, every coefficient for this alphabets as in the simplest fraction, right? This was it for part B. For part C now, it says that this function obtain a series for fx in ascending powers of x up to and including the power 3. Okay, now over here it was 1 plus x. Fx over here is 1 plus x over 2 plus 3x, which can be written as 1 plus x multiplied with 2 plus 3x to the power of negative 1. Further, we can write this as 1 plus x half, then 1 plus 3 over 2x to the power of negative 1, right? They both mean the same thing. So now I can write 1 plus x. This will actually be multiplied with the expansion we did in part B. Half minus 3 over 4x, 9 over 16x square, and then 27 over, this is 9 over 8. Yeah, 9 over 8x square and 16x power 3. From this part, Now I can calculate. For multiplying with 1 of everything will be same. So 3 over 4x, 9 over 8x square, and 27 over 16 x power 3. And for multiplying every number with x, we'll get half x, 3 over 4 x square, and 9 over 8 x power 3. We'll not multiply that x with 27 over 16 x power 3 because then it will make x power 4, which is not needed for my calculation. So at the end now we have half. If you add 3 over 4 and half together, this one turns out to be minus 1 over 4x, and then again 9 over 8 and 3 over 4, as they were both x square coefficients, this one would be 3 over 8 x square, 27 over 16 and 9 over 8. This one turns out to be 9 over 16 x power 3. That is a final expansion over here. And then again after this part, if we move on, there was again a part D. Use algebraic integration to estimate 4 decimal places the integration for this. Okay, now you have to integrate that within the boundaries of 0.5 and 0. Okay, we can do that. For part D, fx integration upper boundary was 0.5, lower boundary was 0. I already know fx can be broken down and written in this format: half 1 by 4, 3 by 8, 9 by 16. So this will be half 1 by 4x, 3 by 8 x square, and then 9 by 16 x power 3. Right, this will be integrated again with the same boundary 0.50, which again gets 1 by 2x. This one turns out to be 1 by 8x square after the integration. This one turns out to be 3, so this will be what? X plus 2 plus 3 is 3, so 3 divided by 3 is eventually going to be 1 by 8 over here also. X power 3. This one is 4. 9 by 16 into 4 is going to be 64 x power 4. As this is integration with boundary, there is no need to include the constant c, so 0.5 and 0. Over here, inputting 0 in the expression will always be 0 because every term in this case has x, right? So the 0 expansion would be 0, but for the half expansion you have to expand that. This will be 0, so 0.5. Again over here you're going to get 1 over 8 0.5 square plus 1 over 8 0.5 power 3, 9 over 64 0.5. Wait, made a mistake. This is x. Oh no, that is correct. After integration, right? Yeah, okay, sorry. X square, x power 3, x power 4, right? This is power 4. Right? In this entire expression has to be subtracted with 0 because when you're going to input the value for x equals to 0 in the entire expression, that will be 0. So if we calculate all these things, you get your value as 0.2256, correct to 4 decimal place. Right? That is your final answer over here, the integration for this binomial expansion. Okay, then that is it for the integration process. Okay, so our next question is again in the power of negative 1 by 3. So we have to again use your factorial theorem. We cannot use NCR for this also. For this part, it says that expands 1 plus 2x in the ascending powers of x up to and including the x power 3 over here. So similar process in this case also, we just have to expand it for the third term. Actually, x power 3 will become the fourth term because you are also going to consider the first term as the 0th term. So let's just start with this calculation. 1 minute. For part A, you have 1 plus 2x to the power of negative 1 by 3. So that means first part is 1 to the power of negative 1 by 3 plus minus 1 by 3, then 2x. Whenever the first term over here in expansion is 1, you do not actually need to include 1 into any of the calculations because anything to the power of 1 will be 1, right? So no worries with that calculations. Next term over here is going to be 1 by 3 minus 1 by 3 minus 1, and then 2x to the power of 2 divided by 2 factorial. For the last term, this is going to be minus 1 by 3 minus 1 by 3 minus 1 minus 1 by 3 minus 2, and then again 2x to the power of 3 entire thing under the 3 factorial. Okay, after this you just have to calculate that minus 1 by 3 is 1, this one is going to be minus 2 by 3x, and then this one should be minus 1 by 3 minus 1 by 3 minus 1, wait 1 minute, and then minus 1 by 3 minus 2, which turns out to be minus 28 by 7 into 2 square, so 2 power 3. Okay, and this one actually turns out to be 8 by 9 x power 3 and 112 by 81 x power 3. So this one's square over here. Okay, and then again we'll include the continuation by adding this plus dot 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 sign. Okay, I mean I think this should only be added over here, not to the final answer. Okay, so after this it says that for part B, find the range of values of x for which this expansion is valid. Now I can clearly understand okay, for which the expansion is valid. This is the range calculation. This question is quite good because you have normal expansion, range, then coefficient comparison, and then again integration also. So this is for part A. For part B, for the range calculation, you always start with this format, that your equation was 1 plus 2x to the power of negative 1 by 3, right? Always remember that whenever you're starting with range, range actually starts with the modulus of x. Okay, so for the modulus of x, this is how the next line will be, that now you have 1 plus 2 modulus of x, and this actually is equals to 0, right? So if this is equals to 0, you are going to get 2 modulus of x, which is going to be 1 over here, because as you are trying to calculate modulus, modulus cannot be negative. I mean this one is actually negative, but eventually this has to be positive over here because we are calculating modulus of x. So negative half is not true, so you are going to get positive half over here because now you are using modulus of x. So for this case you are going to get half over here, right? So if the value for x or the modulus of x is half, modulus always indicates that your value could be negative, could be positive, right? So over here this is the range that you're actually getting positive half, right? So the value over here should be x less than half, right? These are the values over here. This is the final range. This is how you calculate the range. No need to show the working, they will not give you any marks for working, but this is how you find out the range in general. Okay, then for part C, they have again provided you with equation 2 plus kx square with divided by the expansion you did in part A and B. It says that obtain a series for fx in ascending powers of x up to and including the power of 3 and give your coefficient in terms of k where appropriate. Okay, so again we did this in the previous part also, in previous question. Fx is given in the form of 2 plus kx square divided by your original expansion, which was 1 plus 2x to the power of minus 1 by 3. I obviously can expand and write it as 2 plus kx square multiplied with 1 plus 2x to the power of negative 1 by 3, which means now you have 2 plus kx square and everything will be I can expand the expansion, I mean I can use the expansion now, 1, 2 by 3, 8 by 9 and 112 over 8, 1. Okay, so 1, 2 by 3 x power x plus 9 over 8 over 9, 8 over 9 x square, and then 112 over 81 x power 3. If I have to multiply them, this 2, 4 over 3x, 16 over 9x square, and then 112 should be 112 into 2, this turns out to be 224, 81 x power 3, and then again you just have to multiply all the terms with x power kx square, which is going to be plus kx power 3, and then this one with this one would be minus 2 over 3 kx power 3. Oh wait 1 minute, yeah, this is going to be square. Okay, so this is it. Now this is a square over here, and this is going to be cube, right? Up to this format we'll just multiply. We'll not multiply it with x square x power 3 because then it will give you x power 4 and x power 5, right? That is not needed. So now you get 2 minus 4 by 3x. For x square now you have 16 over 9 plus k x square, and then again for x cube you have minus 22 over 4 81 minus 2 over 3 k x power 3. Okay, after this the expansion is done, part C calculation is done. After this we'll move on to part D, right? It says that the coefficient of x cube in the series is actually minus 8 by 3. You have to use this to calculate the value for k. Okay, so the coefficient of x cube was in part D is minus 224 over 81 minus 2 over 3k equals to minus 8 over 3. So now I just have to make 2 over 3k the subject of this formula. So 2 over 3k is actually, or just k the subject of this formula, is actually going to be 224 over 81 plus 8 over 3, and the value for k would be minus 224 over 81 plus 8 over 3 divided by the value for 2 by 3. If you calculate all these things, you're going to get the value for your k as negative 4 over 27. Okay, so after this again part D is also done. For part E, now you have to integrate the entire expression with the boundaries of 0.2 and 0.1. Okay, now the expansion was 16 over 9k. You have to simplify the expansion in order to integrate it. So for the simplification, we'll start with the original equation, which was 2 minus, wait 1 minute, 4 over 3x, then you had 16 over 9 minus k, right? So plus k. So now that will be minus 4 over 27 square, and then again you had minus 224 over 3 minus 2 over 3, which is going to be 2 over 3 multiplied with 4 over 7. So 2 over 3, it gets multiplied with, this one actually becomes positive because k was negative, 4 over 7 x power 3. So if you simplify all these terms, now the expression will be 2 4 by 3x. Second expression now turns out to be 44 by 27 x square, and last one is 8 over 3 x power 3, right? I already know the last one was 8 over 3. Still, let me calculate. 3 plus 2 over 3 with 4 over 7. Wait 1 minute. This was 81. Oh, 4 over 27 this was, sorry, that's why the answer was coming out to be wrong. Yeah, this was 27, sorry, made a mistake. This was 27, right? Eventually it will still be 8 over 3, negative 8 over 3. So this is the expansion. We have simplified it. Now we just have to integrate it further. So integration was in terms of 0.2 and 0.1 fx. So which is now going to be, if you integrate 2, that will be 2x, right? So I'll not write the equation again. I'll just start with the integration. Like I'll start integrating it. This becomes 2x, and the next one becomes 4x squared divided by 3 into 2. So which is going to be eventually 2 over 3. 2 over 3 x to the power of square. Then again 44 with 3 right, divided by 3. That will not simplify anything, so it will be 44. 3 into 27 turns out to be 327 is 81 x power 3, and this one would be 4. 8 over 4 is obviously 2, so you get 2 over 3 x power 4. This is the integrated equation, and this will have a boundary of 0.2, 0.1. So eventually now we have to write both the values for 0.2 and 0.1, as now none of the boundaries over here is 0. Right? If one of the boundary was 0, then I could have easily wrote 0 for that entire expression without actually writing each term separately, like the one I'm doing over here. The first expression has to be subtracted with the second expression. So in between them they have a big subtraction, and this 2 will be changed to 1. Right, this is going to be 1 square, 1, 1 and 1. So if you can write this all on your calculator, you will get the value as 0.1828. That is your final expression for the entire integration. This is the part E of your calculation also, and that is it for your binomial expansion. For this case, we'll move out for you to see this entire maths for one more time. Okay, so yeah, let's move on to the next question. This is again from binomial expansion, and now you have been given with that this expansion is ascending in powers of x up to x power 3. You have to find out the expansion now. So yeah, that is easy. For this case, for part A, the expansion is 1 8x square itself with a power of negative half, which is going to be, first one is obviously 1 to the power of negative half, second one is negative half minus 8x square divided by 1 factorial. Right, we want to find this term up to x power 6 over here. Okay, x power 6 is basically what? X square power 3. That means up to the third term over here. So minus 1, so minus half minus 1 minus 8 square whole square divided by 2 factorial. And then again next one would be minus half minus 1 minus half minus 2 minus half minus 1 minus half minus 2. This entire thing will be in, sorry, not this one, minus 8x square power 3 divided by 3 factorial, and obviously with the plus dot dot sign. And after this, if you just calculate all these on your calculator, this will give you the simplified expressions, which is going to be 1 plus 4x square plus 24x to the power of 4, and the last one would be 160x to the power of 6 plus dot dot dot. Okay, and that is it for part A. For part B now, they have given you the new expression that this equation where a and b are constants. It is given that the fourth and fifth term in the ascending powers of x in the series of expansion are 20x power 3 and 48x power 4 respectively, and you have to find out the value for a and b. Obviously we can calculate that. For part B, gx is given as a plus bx, right? Obviously in the denominator they have the same expansion, 1 minus 8x square to the power half. So if you take that from the denominator to the numerator, and on the denominator you had 1 minus 8x square to the power of half, right? Root means half. So when you're going to take that from the denominator to the numerator, that will obviously become negative with the power of negative. So basically this becomes a plus bx 1 minus x square and then negative half. So which obviously means over here is that at the end you just have to multiply that a plus bx with the expansion you did in part A. So for that part it will be a plus bx multiplied with your 1 plus 4x square plus 24x power 4 plus 160x power 6. If I go back to the question once more, sorry, this is the question. It was stated that the third term and the fourth term is given, right? X power 3 and x power 4 was given only. Okay, so which means if I multiply a with them, it will be a 4 a x square 24 a x power 4 160 a x power 6, and then again after that you have wait 1 minute, I keep on forgetting the question. X power 3 and x power 4, right? I just have to multiply bx with every term. So this one be bx 4b x power 3, and the next term would be 24b x power 5, right? Which is not needed for me, to be honest, because I only need x power 3 and x power 4. So from this case, now again we have right, now we have a bx plus 4a x square plus 4b x power 3 plus 24 a x power 4, and then we also calculated 160 a power 6, so we'll just write it over here. Now I know that the coefficient for x power 3 was 20 and the coefficient for x power 4 was 48, right? Yeah, so I already know that. I'll just start comparing that coefficients of x power 3. They will be what? 20 equals to 4b. So in that case, b turns out to be 5. 20 over 4 is 5, and then again x power 4 is 24a is equals to 48. So in that case, a turns out to be 2. 48 over 24 is 2. So these are the values for a and b. After that, now they again have to integrate it, but this integration is easier because the lower limit over here is 0. So quite easy to integrate this, right? So we will do our integration now. Wait, we have to do the integration for gx, right? First 5 terms they are asking. So first for the first 5 terms, we just have to break this for these cases. 160 or x power 5, they are not needed. So we will start with the expansion first. Gx is, the value for a was 2, so this is 2. B is 5x, the value for a was 2, so 4a becomes 8x square. B is 5, so this one becomes 20 x power 3, and then again we have 48 x power 4. We have to integrate this. So for the integration, with the boundary of 0.2 and 2, you have 2. I'll just do the integration directly, okay? It will become 2, this will become 5x square by 2, this will become 8 over 3 x power 3, this will become 4, so 20 over 4 will actually be 5x power 4, and this will become 5, so 48 over 5 x power 5, and both this entire expression will be within the boundary of 0.2 and 0. Obviously with the lower boundary over here is 0, it makes the integration quite easy because the second part doesn't actually has to be calculated over here, right? Because it eventually becomes a 0. Now for the first part we have to expand it, so it will be 2 0.2 plus 5 over 2 0.2 square plus 8 over 3 0.2 power 3, 5 0.2 power 4, and 48 over 5 0.2 power 5, and this entire thing has to be subtracted with 0, right? And if you calculate all these things, all the term over here, that will give you the integration value for this gx within the boundary of 0, 2 and 2. Just wait 1 minute, let me integrate this. So after the calculation, you get 0.5324 as your final answer, okay? So this is it for the integration of this case. After this, I think we'll move on to kinematics. I'm not sure, let me see. Wait, let me just scroll over the entire maths once again so that you can see this entire thing entirely in one screen, okay? So after this, we'll move on to kinematics. Sorry, factor remainder theorem, right? Factor remainder theorem is not that much tough. I mean, they have given you one expression, one polynomial where they have alphabets of p and q, and it is already stated that x minus 1 is a factor. Always remember, whenever you're working with factors, remainder is always 0 for this case, okay? And this fx, when this fx is divided by x plus 1, the remainder then came out to be 8. Using this information, if the value, you have to find out the value for p and q. So in that case, for part A1, now you are going to get, as a value for p is -2 and the value for q is unknown, you can do this process. X minus 1 is equals to 0. So x would be 1 over here. So if the value for x is 1, and then f1 would be 1 power 3 plus p1 square plus q1 plus 6. This is equals to 0 because the remainder was 0 over here. Always for the factor, the remainder is 0. So this becomes 1 plus p plus q plus 6, 0. So eventually you are going to get your equation as p plus q. This is 7, so this will be -7 on the right hand side. This is your first expression, and then again using the other information that was provided in your question, that x plus 1, right? From x plus 1 again the value for x becomes -1. So in that case, f minus 1 gives you a remainder of 8. It was already stated in the question. So that was that was what? -1 power 3 plus p minus 1 square plus q minus 1 plus 6 equals to 8, which is going to be -1 minus p minus q plus 6, 8. So now you have what? Minus p minus q, -1 plus 6 is 5. You take that to the right hand side, becomes -5. So 8 minus 5 is 3. Or you can take one thing, I'll just keep it like this, okay? Yeah. 1 minute. Sorry, p over here turns out to be positive, right? Q would be negative, but p would be positive. Okay, so this is how the expression is for equation 2. I can easily eliminate the equation. So eliminate 1 from 2 or 2 from 1. This is going to be p plus q equals to -7, and then p minus q equals to 3, which is going to be minus, I do not actually have to eliminate it, q would be automatically eliminated. Then you will have 2p minus 4, and then p would be -2, right? So the value for p turns out to be -2. Using this value for p, I can easily calculate the value for q also. I'll just have to substitute p equals to -2 into equation 2, and then you get p 3 plus q, which is going to be 3 plus -2. Wait, sorry, made a mistake. Let's just input this in 1. Then you have -7 minus q, so you have -7 minus -2, which is +2, so this is going to be -5. So the value for q turns out to be -5. Yep. So that is for part A. A1 and A2, we did found out the value for, this is actually for A1, and this is your calculation for A2. After that, you need to solve this entirely. For solving, you have to write down the expression entirely clearly. You can use long division, or you can use your middle term factorization process. I actually always use factorization, so I would use factorization for this maths, and the next maths we will solve with long division. Okay, so for part B, the actual fx equation was then, 1 minute, x cube, p was -2, so it will be -2x square, it will be -5x plus 6. Okay, so you have x cube minus 2x square minus 5x plus 6. So if you start like substituting over here, or splitting the terms, 2x square and 5x specifically. 1 minute, let me use my calculator to predict the values for the solutions for this equation. This is 3, 2 minus, sorry, made a mistake. First one was 1 minus 2 minus 5 and 6. So you get -2 minus 3 and 1. Okay, so -2 minus 3 and 1. Then I can break this down as x power 3 x square, and since I had 2 over there, right, +1 would be the case, so I can take +1. In that case, I have to take -2 x, sorry, not -2, then I have to take 3 x squared. You can clearly understand minus 3 plus 1 will obviously restore your value for minus 2. That will give you 1 over there. Okay, now using that 1 again, I have to use over here 3x and 2x, not exactly 2. Over here I can use wait 1 minute, you have 5 over there, right? And we are using 1 in this case. No, I cannot use 1 over here because it doesn't clearly add up to be 6 on the last part. Yeah, I should have used minus x square. So this will be again minus x square, and then again over here you're supposed to get minus x, 6x plus 6, right? This should be positive x. Right now this entire thing is equal. For example, both of them were creating minus 2, both of them were creating minus 5, so this is an actual correct splitting. So I can take x square common, so over here it becomes x minus 1, and then between the other two I can take x common, so this will also be x minus 1, and then again minus 6 common, x minus 1. After this you have x square minus x minus 6 and x minus 1. You can middle term this or factorize this easily, which is going to be x square 2x 3x minus 6 x minus 1. This will be positive 2, and then you can take x common, so x plus 2 minus 3 common, x plus 2, and then x minus 1, right? This factorization process of this cubic equation is very less time consuming. I think long division over there is a very lengthy process and time consuming, so I preferably choose to do middle term or factorization for cubic equations also, and I teach all my students to follow this method over here. Okay, now this equation was in terms of 0, like this was equals to 0. So if this equation was equals to 0, that means you have to find out the values for x also. Will not write this in terms of just in terms of the factors only. After this, obviously the values for x becomes x equals to 3, x equals to minus 2, and then x equals to positive 1, right? These are the final value for your expression. After that, we'll again move on to your next equation. This is now in terms of a little bit about factor theorem, and then again about your middle term with powers over here. Okay, so middle term with powers over here is okay, so over here you have the polynomial in terms of a and b, and they have also stated that this time x plus 2 and x minus 1, they are both the factors of this polynomial. So remainder is going to be 0 for both the cases. So you have x plus 2 equals to 0, which turns out to be x equals to minus 2, right? So for x equals to minus 2, f minus 2 is going to be 2a minus 2 power 3 plus minus 2 power 2 b minus 2 plus 3a equals to 0, which is going to be 2 power 3 is 8, 8 into 2 is negative 16a plus 4 plus 2b plus 3a equals to 0, which is now going to be minus 16a, wait 1 minute, a and a are right, you have two a's in the equation, so minus 16a plus 3a would be 15, sorry not 15, minus 13a, minus 13a plus 2b is equals to minus 4, that is your equation 1, and then again the other equation was x minus 1, so for that x minus 1 equals to 0, the value for x is going to be positive 1, so f1 turns out to be 2a1 power 3 plus 1 power 2 minus b1 plus 3a0, and you have 2a plus 1 minus b plus 3a equals to 0, which is basically 2a plus 3 is 5a minus b equals to minus 1. This is again equation 2, and I can usually do elimination easily by multiplying this with 1, this with 2. So elimination would be one from 2, this gives you 13a plus 2b equals to minus 4, and this is 5a minus b equals to minus 1. So from this part I can easily get sorry, wait 1 minute, the second expression would be changed, and this is supposed to be multiplied with 2. So this will be 10a minus 2b minus 2, and now I have the expression simplified. I can easily subtract the two b's together. Eventually I'll have minus 3a equals to minus 6. So a eventually turns out to be positive 2. So with the value for a as positive 2, I can substitute that to get the value for b. I'll substitute that in equation 2. So substitute a equals to 2 into equation 2, which turns out to be b is equals to minus 1 minus 5a. So minus 1 minus 5 2, this is minus 11. So the value for b is minus 11. I actually do not need to want to use any more space, so I will use this, write this over here. So this was the working for part A entirely for your calculations of alphabets A and B in the polynomial. This is the working for part A. Okay, for part B, now you have to factorize this completely. Obviously, I've stated in the first part that I did factorization that I find easier for my calculation, but for others, if you guys find long division easier, then obviously do this using the long division process. So I will do this in terms of long division. So over here, let me use the question again, 2a x b 3a. Okay, so it was 2a x 2b, or it was just b, bx and then 3a, right? This was, I think, the equation is x square minus 3 plus 3a. Okay, in that case the value for b was 2 and the value for a was minus 11. So you have 22, this one will be minus 22 and this one is minus 33. So minus 33 minus 22 actually gives you 55. Wait 1 minute. Minus 1 minus 5 2, yeah, this one actually gives you minus 11, right? So eventually you will have 55, negative 55 x to the power of 3, and then you have minus x square, and then you have minus 2x. We can clearly understand over here the coefficient of constant was nothing, right? So over here that is 0. I mean, that you can write in your equation or not also write in your equation. Another thing for this particular question, right, over here you actually do not need to do entirely long division over here. You can actually middle term this easily without doing any long division. So for example, over here, wait 1 minute, sorry, the value for a was 2 and b was minus 11, right? 1 minute. Wait, yeah, that's what I was saying, that every time the calculation turns out to be negative, right? This one is negative. That's big. For that reason, over here you are actually going to get positive value for 11. Okay, now the value for b is 11. I have to recorrect this again. So a was 2, so this will become 4 and this will become 6, right? Yeah, 4 and 6, this becomes 10 x cube minus x square, and this one becomes negative 11 x. Now I can do one thing, I can take 1x common, and that will be 10x square x and 11. From this part again, I already know the factors for this equations are 2 and 1. So this is going to be, I can directly split it. Now this is going to be like what, 20x 1 minute, yeah, that was plus 20. So if this is plus 20, then I got minus 1 over here, right? Oh wait, sorry, I cannot actually add them together, right? Sorry for creating this entire mistake. This is going to be just 4x cube, this is x square, this is 11x, and this is just 6, right? Because it doesn't have any x over here, right? This is just 6. Now I have to do long division. Okay, I'll do long division. I mean, I can still use factorization, but I'll do long division over here for better explanation. I already know the factors for this polynomial were x plus 2 and x minus 1. I'll use x minus 1. So for the first part, x minus 1, I always divide the first part of the polynomial with the first part of the dividend. So 4x square divided by x turns out to be 4x square. So this was 4x cube. So now you have 4x square. So 4x square multiplied with x minus 1, 4x power 3 minus 4x square. So 4x power 3 minus 4x square. If you subtract them, this one gets cancelled out, and eventually this is plus and minus. So this is going to be what? This is plus 4 and minus 1. So 3x square minus 11x. Similar process, I'll divide the 3x square over x to get 3x. So I'll write 3x on the numerator, on the quotient space, and 3x multiplied with x minus 1 gives you 3x square minus 3x. So 3x square minus 3x, and divide it, or subtract it. So 3x square gets cancelled out. This 3 over here is positive. Minus 11 plus 3 will actually give you minus 7 plus 6. Wait 1 minute. If I'm going to minus 6, in that case the remainder won't be 0 in that situation. Am I making any mistake? 1 minute. That is 1, 11 and 6, and wait, minus 1 minus 4, this is positive 3 and 11, so 3, right? So you're going to get minus 11 minus, 11 minus 3. You're going to get minus 8 over here, sorry. Okay, minus 8. But then again, dividing minus 8 with x gives you minus 8. This is not 2, so this won't give you the same value. That is not how it was supposed to work, because x minus 1 was also a factor, right? If I'm not wrong. Let me go back. Right, x minus 1 are both factors, so the both of them should actually give you the remainder 0. But wait, maybe I am creating some mistake over here. 1 minute. Let me just figure this out. 4 into 4 is 4x square. This is 3. This one over here was actually positive. I read the question wrong. If this was positive, in that case, so sorry for this. This was supposed to be 5x square minus 11x, and over here now you're going to get 5x, right? So this is going to be 5x square is in the rough working also, so 5x, and now you're going to get 5x square 5x. If you now introduce minus over here, this one gets cancelled out, and this one will give you 6x plus 6, which is basically 6x divided by x gives you minus 6. So minus 6 and minus 6, x minus 1 gives you minus 6x plus 6, minus 6x plus 6. Right, now they will obviously cancel each other out. From this point onward, I can write this polynomial fx. The polynomial was 4x cube plus x square minus 11x plus 6, right? I can break this down as x minus 1 and 4x square plus 5x minus 6. And from this part again, I have to middle term that factorization also, which is going to be 4x square. Over here we can write 6 and, no, not 6, 2 and 3 can be written as, not 3 again, 1 minute. Over here I have to take 2 over here, right? We can write 8 and 3, sorry, 8x and 3x minus 6, and then x minus 1, we can take 4x common, so it will be x plus 2, then minus 3 common, then again x plus 2, and lastly we have x minus 1, 4x minus 3 and x plus 2 as your last 3 common factors. This was again in terms of equals to 0, where you have to find out the value for x also. So in that case the value for x would be 3 over 4 and minus 2, right? This is the value for your x. After this last part, I mean this is it for your factor theorem, long division part B, I think, right? After that, now they have introduced one polynomial like this, and now you have to find out the value for y over here. If you zoom in, this is 2y plus 2, 3y plus 2, 2y, 2y, 3. Okay. For part C, previously you worked with fx, which was 2x power 3, not, was it 2x power 3? No, sorry, I made a mistake. It was 4x power 3, sorry. It was 4x power 3 plus x power 2 minus 11x minus 6, right? These were your, say, plus 6 over there. This was your original polynomial equation. Now they are introducing hx over here, or hy, where this is basically 3 power y plus 2, then 2 power y, then 11 2 power y, then again plus 6. Okay, so for this part again I can write this 3 power y. They have a plus in the power format, so this is going to be 2 power 2 plus 2 power y whole square minus 11, sorry, I made a mistake. This is 11, wait, this was again, I think, wrong. This was again in this format, 2 power y, 2 power y plus 6. Okay, from this part I can write this as what? 4, 2 power square is 4, and then this 2 power 3y can be written as 2 power y power 3 plus 2 power y square minus 11 2 power y plus 6. You can assume that 2 power y to be x. Then the equation is 4x cube plus 2, not exactly 2, this is 2 power y itself, so this is going to be x square minus 11x plus 6. Now you can see that this equation and this equation is entirely similar, right? So the values for the solution for the previous equation that you got was 3 over 4, 1 and minus 2, right? Those were the equation. Just 1 minute, my tab is updating for some reason. Yeah, 1, 3 over 4 and minus 2. So in that case I know that the solutions from this case would actually be x equals to 1, x equals to minus 2 and x equals to 3 by 4. 1 minute, 1, 3 by 4 minus 2, 1, 3 by 4 minus 2, right? In that case, if the values for 1, 3 by 2 and, sorry, 3 by 4 and minus 1, so now using these you can you can consider then again writing them as 2 power y is equals to 1, 2 power y is equals to minus 2, and then again 2 power y is equals to 3 by 4. For example, over here I can clearly understand 2 power y would be 2 power 0, because anything to the power of 0 turns out to be 1. So the value for y is 0, first value for y is 0. Second value over here, as you have negative value, always remember for negative value you cannot get any answer, because if you try using log in this case also, that would be what? Log, wait 1 minute, log minus 2 divided by log 1 minute, log 2. That again becomes math error. Okay, so you cannot actually get any solution from this part, but from this part you can introduce log, that log 2y, log 3 over 4, and if you just make y the subject of this equation, it will give you log 3 over 4 divided by log 2. So you are going to get log 3 over 4 over log 2, and that would be negative 0.451. okay, that is another value for y. So negative 0.415, not 5115. These are the values for y then. So yeah, that's it for the two solutions, right? There will be no solutions for x equals to minus 2, but there will be solutions for 3 over 4 and 1. So yeah, this is it for your polynomial theorem or factor remainder theorem, and then we'll move on to kinematics, to the next section, right? This is also quadratic equation. Okay, we'll start with the quadratic. I think I could only find one quadratic equation, and then we'll move on to kinematics. Okay, so this is quadratic equation. They are saying that use binomial expansion to expand these and show that this can be written in this format. Obviously we can do that, x plus y to the power of 3, right? Now we can use the NCR format because there the power is positive and in whole number or integers, so it will be easier for me to do this entire process using the NCR format. So x plus y to the power of 3, that means for the first part this is going to be x power 3, then this is going to be 3c1 x power 2 y, and then 3c2 x power 3 minus 2 is 1, and then y power 2, and then lastly 3c3 x power 0 would be 1, so I'm not writing that anymore, and y power 3. So if we calculate the values for 3c2 or 3c and 3c3 and 3c1, 3c1 3c1, right, this is 3, this is going to be x power 3, this is 3x square y, and this one is 3c2, this is 3xy square, and then lastly 3c3 is 1, so this is going to be y cube over here. But problem is we had to prove this statement over here, right, which was entirely in terms of y, not in terms of x. So we expanded this. So for first part we have to just expand this, right? We did the expansion, that is it for first part. For the second part, now this portion is for the part B, that this expansion has roots alpha and beta. Without solving the equation, find the value for alpha cube and beta cube. Okay, so for part B now, they have provided you with equation 2x squared 3x and 4, 2x squared 3x and 4 equals to 0. Obviously alpha is always the value for your minus b by a, right? So minus b by a, which is going to be minus 3 over 2, and beta is always c by a, which is going to be positive, let me write this down, c by a, which is 4 by 2, which is eventually 2 over here. So that is the value for a, alpha and beta. Now they want to find out alpha cube and beta cube, that we can find out, but obviously we'll first have to do the sum of products and sum of roots and product of roots. So sum of roots, SOR, that is alpha plus beta, which turns out to be minus 3 by 2 plus 2, which is this is 2, and 1.5 minus 1.5 plus 2 is just 0.5. And product of roots, that is alpha and beta, which is minus 3 by 2 and 2, this is minus 3 now. Okay, from this point now I'll do the I'll start working with the explanations or expansions of alpha cube and beta cube. Alpha cube and beta cube has a formula, alpha plus beta whole power 3 minus 3 alpha beta, alpha plus beta. Now there are formulas for alpha square plus beta square, alpha plus beta whole square, alpha plus beta whole cube. All those formats has to be memorized before your exam tomorrow. Okay, so alpha plus beta whole cube, this one will be alpha plus beta was negative 3 over 2, this power cube, this is 2, and this was again 3 over 2. So if you calculate all these things, you're going to get a value of 45 over 8. That is the value for your alpha cube plus beta cube. This was for part B. After this, it says that hence find a quadratic equation this time with integer coefficients whose roots are alpha plus beta, like alpha by beta cube and beta by alpha square. Okay, now we are going to use the same value for alpha plus beta and alpha with beta, like the same sum of roots and product of roots will remain same, but for this new equation, this is part C, roots over here are alpha over beta square and beta over alpha square. So in this part now I will start with again sum of roots. Sum of roots is alpha over beta square plus beta over alpha square, which is going to be, if I take the denominator as a product, alpha square beta square, this is going to be alpha square multiplied with alpha and beta square multiplied with beta, which is eventually alpha cube plus beta cube, and alpha square plus beta square, and alpha beta square can be written as alpha beta whole square. Alpha cube plus beta cube was 45 by 8, and alpha beta was, like, product was 2, so this is 45 by 8 divided by 2 square, which is now going to be eventually 45 by, I think this is 32, right? 8 into 4 is 32. So this is going to be 845 over 32. That is the value for your sum of roots. And then again product of roots. So product of roots, that is going to be alpha over beta square multiplied with beta over alpha square, which means that this will be cancelled out, this leaving you beta 1 in the denominator. This gets this, and this means you have 1 left in the denominator. This basically turns out to be 1 in the numerator and alpha and beta in the denominator, which is half only. So now at this part, in order to create the new equation, the format was always x square minus sum of roots multiplied with x plus product of roots equals to 0, which is going to be x square. Sum of roots was itself 45 over 32x plus half 0. Now in this situation, you just have to make 32 and 2. You have to do LCM over here. So if you do LCM, this becomes again 32. So if the LCM is 32, this becomes 32x square minus 45x. 32 divided by 2 is 16. So this one will be 16 equals to 0, right? This is how you are going to create the equation for your quadratic equations. Okay, after this is the end for your quadratic equations. We'll move on to your next question. These are from kinematics. So for kinematics again, it says that the point with coordinates 4 minus 104 lies on the curve with equation this one, and they have also provided you with the integrated equation. This is an integrated equation. Sorry, this is not exactly from kinematics. While I was creating this file, I made a mistake. This is from coordinate geometry. We'll come back to this part whenever we are going to start with coordinate geometry. That is at the end of your paper. So this is the end of your paper. Okay, so I'll have to skip this and we'll start with this one. This is from kinematics. Okay, a particle P is moving along a straight line which passes through the fixed point origin O, where it is given that t is greater than or equals to 0 and the velocity is v meters per second. This is your equation for velocity. At time t equals to seconds, the acceleration of p is a. Find an expression for a. Over here I already know that displacement, differentiation of displacement gives you velocity, therefore differentiation of velocity will give you acceleration. So for part A, in order to create acceleration, just do dv by dt. That is going to be what? It was t square, so it will be 2t and minus 3. That is the value for your acceleration over here. After this, displacement of p from A is 7 meter at 2 seconds. Now you need to find out the displacement, like exact displacement of p from O when t is equals to 4. That means there must be some turning points involved over here also, right? Because this particle p was traveling or passing through point O 2 times at t equals to 2, at t equals to 4. So what we have to do over here is this, that I have to find out an expression for the displacement. Okay, I can find out the expression for displacement, but then again they want you to find out the exact displacement of p from O when t is equals to 4. This is how the entire thing is working. This entire object started of p from O, started from point O, right? This is point O, origin. From this part, this is how the particle was actually traveling. And it was also stated that the displacement of p from O is 7 meters. This is like the total p of p from O. Like this is the point when the particle was at this position. I do not know what position. This distance was 7 meter. I do not have any name for this. And at this point the time was 2 seconds. And now they want to find out the exact displacement of p from O when t is equals to 4. So when t is equals to 4, I actually want to find out that what would be the distance traveled between these the next 2 seconds. 4 t equals to 4 means that from this second, like t equals to 2 part, maybe over here this is t equals to 4. I want to find out the distance in between them. So in order to find out the distance in between them, if I have the equation for velocity, to go back to the equation for displacement, right? Over here they're talking about displacement also. Over here, if you want to go back to your value for displacement, in that case you have to integrate the equation, and in this case integration will be in the boundary of 4 and 2, right? because I want to find out the displacement of P from of O, like the displacement of the particle from O when t is equals to 4 seconds. Okay, so for part B, this is the equation will be displacement, that is 4 to, equation was t power square 3t plus 4, which is going to be t power 3 over 3, then 3 over 2 t square plus 4t, and obviously with the boundaries of 4 and 2. If you input the value for 4 into the equation and then subtract this expression with 2 inputted into the expression, this will give you 47 by 3. Okay, so I'm not calculating that, but you have to calculate that. I'm just explaining you the overall process and method for this. This is 47 over 3. After this, again we'll move on to the next question. A particle P is moving along the x-axis at time t seconds, where t is greater than or equals to 2, and the velocity of P is v meters per second, where this is the expression. Okay, find the velocity of P when t is equals to 1 seconds over here. That is clearly easy. I just have to input the value for 1 into the equation to get the value for that velocity of particle P. So this is going to be 1 square minus 10 1 plus 28, which is 1 minus 10 plus 28, right? What will be the value? 19 over here. So positive 19 meters per second. After that, given that the distance of P from the origin is 24 when t is equals to 0, find out the distance of P from the origin when t equals to 5. Similar case, right? Now we have to do integration again all over this time, and using the integration there will be the boundaries of what? 5 and 3, right? So similar to the last question. So displacement we want to find out, integration with boundaries 5 and 3, it was t square minus 10t plus 28. Now this one will be 1 over 3 t power 3. It will be t square, so 2 divided by 5 or 10 divided by 5 will actually make it 5. 10 divided by 2 will make it 5 t square plus 28 with the boundaries of 3 and 0. You obviously have to write the case where we are inputting the value for 5 and 3 into the equation and then subtracting the two expressions together. This will actually give you the final answer as 98 by 3. This is your final displacement of particle P from the origin when t is equals to 5 seconds. After that, again they want to find out the acceleration of P when t is equals to 9. For acceleration you have to differentiate, right? We did this in the previous question also. So for A, this is dv by dt, that will be 2t minus 10. I already know I want to calculate this for t equals to 9. So this is going to be 9 minus 10. That is 18 minus 10 is 8 meters per second square. That is the value for your acceleration of particle P when t is equals to 9 seconds. Then again it says that show that there are no values of t when P is instantaneously at rest. Always remember, when P is instantaneously at rest, velocity is always 0. And then again you have to represent that the at least magnitude of velocity P, the smallest magnitude for velocity of P. Okay, smallest mean the minimum value. Okay, for minimum value we always either differentiate it or you do completing the square. You can do both things over here, but I would suggest using the completing the square because then it's just easier and less time consuming for this point. Okay, now for part D1 over here, I want to show that they do not have any point where the object comes to at 0 position over here. Okay, yeah, where the object will be at rest over here. Okay, that means over here the they're actually indicating that you can actually calculate the minimum value and then suggest that at all point of the journey there won't actually any point where the object was at instantaneously rest. At every point the object had some velocity. So for that, let's just find out the completing the square format. Original equation for V was t square minus 10t plus 28. Right, in that case for completing the square we always write this in format of a x plus capital B whole square plus capital C. For capital A, format is always a, which is over here 1. So capital A is 1. Capital B is b by 2a, which is minus 10 by 2 1, which is minus 5. And then C over here is c minus b square by 4a, which is 28 minus 10 square divided by 4, 1. This will give you 3 plus 3. Let me check again, 1 minute. 28 3. Okay, now after this I will write the expansion as a value for a was 1, so let's not write anything on that part. X minus 5 whole square plus 3. As I already know, this was a positive quadratic equation, so from this part the minimum point will be also, the equation will not actually have x, it will have t, right, because it was in terms of t. So now the minimum point will be, the coordinates for the minimum point is minus 5 and 3, right. This one indicates that the least y coordinate value is 3. The value cannot be less than 3. So over here the minimum point, or we can write that if v over here is greater than equals to 3, it cannot be less than 3. That is the range. If I am going to draw it on a graph, this is how it will look on a graph. This was for a positive quadratic equation. So this is a positive quadratic equation. This is what? Minus 5 and 3, right. The x-axis over here is minus 5 and the y-axis was 3. That means the value for your v can never be less than 3. It has to be greater than 3. On your y-axis you have time, so on x-axis you have time, and y-axis has velocity. Okay, now again after this they want to find out the least value for t. I already know the least value for t, right. So for part 2, least value is 3. That is the minimum value over here. Least value is 3 meters per second. This was for part 1. So yeah, this is it for kinematics second question. This is your third question. A particle p is moving along the x-axis, and at time t equals to at time t seconds, the velocity of v is given by this expression. We need to find out the acceleration of p when t is equals to 5. Again easy. For t is equals to 5, acceleration, right. So this is going to be dv by dt. That is 4t minus 16. That's 4, 5 minus 16. That's 20 minus 16 is 4 meters per second. 20 minus 16, right, 4 meters per second. After this again you have find out the exact value for mn, but it was stated that p comes to instantaneous rate as rest at point m and n. At both these points the object will be at rest. So for this case, wait 1 minute, at time t equals to 1, at t equals to 2 seconds. So m is for t equals to 1, n is for t equals to 2 seconds. And now you have to find out that where it was already stated that t2 comes after t1, so it will be greater than t1. You have to find out the exact distance in between these two cases. Let's first find out the values for t2 and t1, then you have to display, like, integrate it within the boundaries of t2 and t1. That's what it says over here. So first find out the values for t1. At instantaneous rate we already know v is equals to 0. So you have 2t square 16t plus 30 equals to 0, which is going to make it very easier for us to do the middle term. Over here if you do the middle term, I'm not doing this, but if you have to continue do the factorization. If you can factorize this, t1 turns out to be 3 and t2 turns out to be 5. Now I have the boundaries. They want to find out the distance in between these two times, right? So using this distance I can easily get the value. Integration of v with the boundaries of 3 and 5, which is going to be 2t square is going to turn out to be 2 over 3 t power 3. This is 16 over 2, which is going to be 8t square plus 30t within the boundaries of 5 and 3. Again, I'm not inserting the values in the equation, but if you insert it, you have to insert 5 into the expression and then again 3 into the expression. Subtract the two values. At the end, you're going to get 8 over 3 meter as your displacement. Okay, this is it for your part B again. That is the end for your kinematics. We will move on. I kept a lot empty space for these cases. Okay, now we'll move on to trigonometry. For trigonometric equation, this is quite tough. And then again for trigonometric equation, we will actually require the chart we drew for this case, for the second value and third value, right? We would actually need this one. For trigonometric equation, we would need to find out the first value and second value, so this is needed. Right, I'll just keep this over here. Okay, now for this part, for this first one, it says show using formula on page 2, show that sine 2a is equals to 2 sine a cos a. Without, I took this from the question papers, but even without help of that, we can add this. For part 1, sine 2a, we need to show this is equivalent to sine 2a and cos a, right, if I'm not wrong. Right, sine 2a cos a. We can express this as sine a plus a, which will be broken down as sine a cos a plus sine a, so not plus, as you have plus in the middle, so you are going to get a negative sine a. Oh wait, no, sorry. Wait. Yeah, in this case, you're going to get negative sine a. Wait, you have 1 minute. Sine a cos a, right? Sorry, sine a sine a. Sine a cos a, and this should be cos a sine a, right? This should be cos a sine a. And obviously in multiplication, we can write anything in front or back, right? Like 2 into 3, 3 into 2, both will give you the same procedure or same answer. So instead of writing cos a sine a, I can write sine a cos a, and that would, oh wait, that would actually eliminate the values over here. No, 1 minute. No, this was supposed to be then positive over here, right? I made a mistake. This was supposed to be positive. If this is not positive, then they get eliminated. So no, this is positive over here. So this is cos a. Now I can write this is what? 1 sine a cos a, 1 sine a cos a. They're going to add it together. So obviously this will leave you 2 sine a cos a. Right? This is your final shown maths for part 1. For part 2 again, they are saying that cos 2a is equals to 2 cos square a minus 1. You have to show that cos 2a can be written as 2 cos square a minus 1. Okay, so for part 2, cos 2a can be written as 2 cos square a minus 1. So we're going to start with cos 2a. Cos 2a will again be written as cos a plus a, which is cos a minus sine a sine a. Similar thing multiplied twice gives you square, so this is basically cos square a and sine square a. As you know, final statement, it was all written in terms of cos, so I'll break down this sine square in this format. That sine square a is actually 1 minus cos square a, right, which makes this cos square a minus 1 minus cos square a, which is basically cos square a minus 1 plus cos square a. So you have 2 cos square a, so I can write 2 cos square a minus 1, right? 1 cos square a over here, 1 cos square over here, and they were added together. So obviously you're going to get 2 cos square a minus 1, and that is your final statement. That is your answer. After this, again we'll move on. Now they have provided you with the equation f theta 2 tan theta over 1 plus tan square theta. This can be written as this sine 2 theta again. So okay, let's start with this. This is, I think, part B. Okay, so for part B again, you have f theta 2 tan theta 1 plus tan square theta. Okay, now over here I can break down tan in terms of sine over cos, right? So in the numerator now I can break this down as 2 sine theta over cos theta divided by 1 plus, on the denominator also we can write sine squared theta over cos squared theta, right? So this will be sine squared theta over cos squared theta. So I can revert it, will make the denominator quite easier. So it will be 2 sine theta divided by cos theta divided by cos square theta plus sine square theta divided by cos square theta. Okay, now again I will this is your entire denominator, right? I will invert the denominator and multiply with the numerator. So now I'll write the numerator like this: cos theta multiplied with cos square theta divided by cos square theta plus sine square theta. Obviously this one will be what, 1, right? Because cos square theta sine square theta is equivalent to 1, and this one gets subtracted with this one or cancelled out with this one. At the end this one is 1 also. So you're going to get with 2 sine theta and cos theta, right? Then again lastly, I already know from my part A1, 2 sine theta cos sine theta can be expressed in terms of what? 2 sine A, right? So sine 2A. That is because I can break this down as over here as sine theta cos theta plus sine theta cos theta, or actually in the format of cos theta sine theta. This is exactly in the format of sine 2 theta that we did in first part A1, right? This is your working for part B. After this again we have part C, where you have to use trigonometric equations this time. Now they are saying that find out the values for the x, right, in radians within the range of minus pi by 2 with minus positive pi by 2. Okay, now the equation that they have used is quite very big to work with, right? They have x plus pi by 6 as the final value. So I'll just like write this or copy this to my area where I'm going to do the maths. Okay, now over here you have I'm going to consider this x plus pi over 6 as theta for my simplicity. Okay, so now you have 5 tan theta, 1 plus tan square theta, and then 1 minus 2 cos square theta. Okay, previously we had started with 2 tan theta, 1 plus tan square theta, 1 minus 2 cos square theta, right? Okay. In part B2 we calculated A2, we calculated that 2 cos square theta minus 1 was there, but not 1 minus 2 cos square theta. Okay, 1 minute. Yeah, 2 cos square A minus 1, that was the value. Now we cannot actually find anything similar over here. 2 cos square theta. Okay, let's just start doing this. I think as we continue doing this, we'll get an idea over here. One thing we can do over here is that I will subtract 3 tan theta from both sides of the equation. Oh no, then that will not work also, right? No, that we cannot do. One thing we can do is 1 minus 2 cos square theta, right? there's something, in some way we can express this in another format. 1 minus 2 cos squared theta. We calculated cos squared theta minus 1. That can be represented as cos 2 theta. Now over here, let's just start doing this. Tan theta, this is 1 plus tan squared theta. If I can actually take minus common from that part, that would be 2 cos squared theta minus 1, right? Now this one resembles your value for cos 2 theta that we did in part 1, A part 1. So this becomes 5 tan theta, 1 plus tan squared theta minus, this is going to be cos 2 theta, right? Not exactly minus, this minus is also actually multiplied with the tan theta. So minus cos 2 theta is what you're getting over here. And then again for this minus cos theta, I mean for minus cos 2 theta over here, then again there's nothing you can actually get out of this. Yeah, you can multiply this with 1 cos 2 theta, and then tan square is going to be what? Then no, actually this one doesn't actually give you any solutions for this case. I'm considering that 5x plus pi by 6 as a whole theta. So yeah, 5 tan theta there's no way this is like, similar to the previous maths. I'm trying to connect it with the other sections we did for part A1 and then B1, but we cannot connect it anyhow over here. I cannot connect it over here anyhow. 1 minute, let me just go back again. Cos 5 theta plus 2, okay. In part B also they wanted to show you sine 2 theta. We did that for sine 2 theta, but for part C it's actually creating a mess over here for part C only. Well, this won't actually give you any solutions. Okay, the first line was actually correct. Okay, other than that, this won't actually give you any solutions. We can try to break this in terms of cos and tan. So this would actually be what? 5 sine theta divided by cos theta. And then again this one would be 1 plus sine square theta over cos square theta. And this is already in terms of 1 minus 2 cos square theta. So this one over here is 5 sine theta over cos theta, and this is, if you multiply them, 1 into 1 is 1, 1 into 2 is 2 cos square theta. This is sine square theta minus cos square theta, and then again multiplication of sine square theta by cos theta with 2 cos square theta. These two will be cancelled out, right? We are going to eventually left out with 2 sine square theta. Okay, now it makes sense. Okay, 5 sine theta divided by cos theta. You're going to write 1 minus sine square theta over cos square theta, and this 2 cos square theta, 2 sine square theta. If you write them together and take the minus common, 2 cos square theta plus 2 sine square theta. And again take this 2 from them common also. So this is what? Cos square theta plus sine square theta is 1, right? So we are going to get 1 minus sine square theta cos square theta equals to minus 2, which is eventually going to be 1 minus 2 is minus 1 minus sine square theta and cos square theta, which is now 5 sine theta cos theta. Also over here you have 5 sine theta cos theta. From this part, this is what? This is 5 tan theta minus so equals to minus 1 minus tan squared theta, right, which you can write this as tan squared theta plus 5 tan theta minus plus 1 0, which is going to be tan squared theta plus 4 tan theta plus tan theta plus 1 0, which is now going to be, if you take tan theta common, it is going to be what? Tan theta, oh no, we cannot do that. You have the values for 4 and 1, that is 5, but on the other side you have 1. No, you cannot do that. Let's do the middle term on calculator. Let's see if this has a solution. 1 5 5 1. Now this turns out to be in decimals. The solutions over here turns out to be in decimals. Okay, so you have to do the formula method for middle term to calculate the values for theta over here. Now again, the formula method was minus b plus minus b square minus 4ac under a root and everything divided by 2a. Okay, so when you do the values over here, you are going to get one value is I'll try to keep the answers as a whole number, minus 5 minus 21 2, and the other one was, I think, minus 5 plus, right, minus 5 plus 21 over 2. Okay, now after this I can calculate the values for actual theta was not just theta, actual theta was x plus pi by 6. So I would have to subtract pi by 6 from both the values. Then again, this one actually turns out to give me, this is also in terms of tan theta, by the way. Okay, tan theta is this value. So in that case, tan theta will actually give you, like, we are now trying to find out your first calculated value. Okay, so tan inverse minus 5 minus root 21 over 2, and then again tan inverse minus 5 plus root 21 over 2, right, that will give you the value. So obviously change your calculator's mode to radian, which is going to be tan inverse minus 5 minus root 21 over 2, which is going to be negative 1.37, and for the second part, tan inverse minus 5 plus root 21, this is negative 0.206. Now over here, problem is your range was within negative pi by 2, right, pi by 2 to positive pi by 2. Let's find out pi by 2 in decimals, that is 1.57. So within the range of negative 1.2757 to 1.57. okay, now over here your first calculated value is negative, but that is not a problem. You already got two different values, right, and both will be accepted. So you have to find out the second value and third value with reference to these cases. Yes, you have to find out the, wait 1 minute. Now you have to find out the values for this second value and third value with reference to this. Wait another minute, 1 minute. So in that case, the values for the second value and third value, what would I do for tan? It was 180 plus first value, right? So in that case, or over here it is going to be pi plus first value. So now over here you are going to get for the second value for both the data, this is going to be pi plus, but obviously the angle over here is negative, so it will be 1.37 negative, and then again over here pi minus 0.206, because the angle itself was negative over here. So pi minus 1.37 will be 1.77. that is obviously greater than your pi, right? So we're not going to calculate that. Pi by 2, the range over here was between 1.57, this one gives you 1.77. Let's just calculate this still. This was later, yeah, this is 1.77, and then again pi minus 0.206, This one again gives you 2.94. Both of them are outside the range, so that means we're not going to calculate anything extra, or no, we actually have to calculate anything extra. This one gives you 1.37, 1.77, and then negative 0.206, and then again 2.3031, I think, right? And then these are the values for theta, right? But you assumed that x plus pi by 6 as theta. So in that case, now we can write these are for x plus pi by 6, right? These are for x plus pi by 6. So now we can find out the value for x, which is going to be pi by 6 subtracted from all the data. So over here x would be minus 1.37 minus pi by 6, and then again 1.77 minus pi by 6, and then again minus 0.206 minus pi by 6. So even though your values were actually outside the range, but whenever you're going to subtract another pi by 6 with that, it might fall within the range of 1.57. So then you're going to get minus 1.37 minus pi by 6. This gives you negative 1.89. Negative 1.89. So now this will be cancelled out, right? Then you had 1.77, positive 1.77. This one now gives you 1.25. Now this one falls within the range. Then you had 0.206, negative 0.206. This one gives you 0.73. This is still within the range. And then lastly you had 2.31, which was 1.77, right? Now from this case we can understand that only the values that will fall within the range is 1.25 and negative 0.73. These are the only values for x that will be added, because this falls within the range. This is for your trigonometric equations. I hope this was clear for all of you. This was for part C, I think, right? But then again they asked for part D also. For part D, I think we have to integrate something, right? For part D again we also have to integrate it, as we don't have much space. So we'll do the integration over here in this page, okay? So integration was actually within the range of pi by 2 and 0. Wait, why this in the smart select is on again? Wait 1 minute. No problem, I can remember this equation. It is 4 tan theta 1 plus tan square theta cos 5 theta plus 2, okay? For tan theta 1 plus tan square theta cos theta plus 2. Cos 5 theta pi by 2 range, it was minus, okay? Okay, over here you had cos 5 theta. In terms of d theta, you have to integrate it within the range of pi by 2 and 0. If the lower limit is 0, I already know the next term would be 0. Over here, we have to simplify the equation first. For example, 4 tan theta 1 plus tan square theta can be written as 2 tan theta 1 plus tan square theta cos 5 theta plus 2, right? It can be written like this also, where tan theta, 2 tan theta plus 1 plus tan square theta actually gives you sine 2 theta. So this is going to be 2 sine 2 theta minus cos 5 theta plus 2. Then again this sine 2 theta can be written as 2 sine theta cos theta, and then you have cos 5 theta plus 2, right? Okay, you have cos 5 theta over here. No, let's write it like this and then start the integration over here, just the way this is. For example, integration of tan theta would be, the 2 from this part will come in front. So I mean, we have simplified this entire expression. We will now with the integration, okay? Pi by 2 0 d theta. So now with the integration, this becomes sine, integration of sine becomes negative cos. So you have 2 cos 2 theta divided by 2. Obviously the 2 gets cancelled out at the end. Then integration of course becomes sine 5 theta by 2 plus 2 theta, right? Obviously it was in terms of theta, so and then upper boundary was 0 and pi by 2 and 0. Now this turns out to be negative cos 2 pi by 2 and then minus sine 5 pi by 2 plus 2 pi by 2, right? This entire expression will be subtracted with 0 again. So if you calculate all of these things, your final answer should be in terms of 9 over 5 pi. That is your final answer for the integration of this trigonometric equation. After this, we'll move on to your next equations, next calculations. This is again similar kind of, we have to do trigonometric identities for 9 part 1 and 2, cos square a cos 2a plus 1 over 2 and then sine square a 1 minus cos 2a by 2. Okay, so for part a, cos square a cos 2a plus 1 over 2 over 2. Over here now you have these are, you have to just show this. So on this case again, cos square 2 cos 2a plus 1, right? Cos square a over here can be represented as wait 1 minute. Now this was cos 2a, right? We can work in either way, to be honest. I can work with the left hand side or with the right hand side. They are asking you to calculate cos square a over here. Okay, let's start with the left hand side this time. Cos 2a plus 1 divided by 2. Okay, and cos 2a can be broken down as your what value for cos 2a can be cos a cos b, sorry, cos a plus a. That can be one of the processes. And if you're using cos a plus a, cos 2a is cos a plus 1 over 2. Cos a plus a can be written as cos square a. Cos square a it becomes, because it is cos a and then minus sine a, right? So in that sense you are actually getting this is plus 1 divided by 2, and again over here you're going to get cos square a minus sine square a plus 1 over 2, which is going to be cos square minus sine square is actually going to be 1 minus, sorry, now I can write cos square a minus 1 minus cos square a plus 1 divided by 2. From this part, if you remove the brackets, now you have cos square a minus 1 plus cos square a plus 1 divided by 2. So in that case, 1 and 1 gets cancelled out. You have 2 cos square a divided by 2. Eventually you just have cos square a, because this 2 gets cancelled out. At the end, this is the solution for part A1. After this, for part A2, you have sine square a 1 minus cos 2a over 2. So for part 2 again, sine square a 1 minus cos 2a over 2. Similarly, I will actually start working with okay, I can work with any, yeah, I know I'll actually start working with the same procedure. 1 minus cos 2a, we'll start with cos 2a class parts. So it will be 1 minus cos a plus a over 2, and then again you have 1 minus cos A minus sine A sine A, right? This was actually in front of a minus, so this would be a positive this time, divided by 2. So this time I have 1 minus cos square A plus sine square A divided by 2. This itself creates sine square A, right? Because sine square A plus cos square equals to 1. Therefore, sine square A was actually 1 minus cos square A. So in that case, this one creates sine square A plus sine square A divided by 2. Obviously, this one gives you 2 sine square A divided by 2, eventually giving you sine square A. That is your format that you have to show in your answer. That is the answer for part A. After that, you have to show that 2 sin x cos x, sin x minus 3 sin cos x can be written in this format. Okay, doable. Let's start with 2 sin x minus cos x, sin x minus 3 cos x. Okay, 2 sin x minus cos x and then sin x minus 3 cos x. So we'll just multiply them. For example, now you have 2 sin square x minus 6 sin x cos x, and then again this one would be minus sin x cos x and plus 3 cos square x. Eventually you have 2 sin square x minus 7 sin x cos x, 3 cos square x, right? This is it. After that, I think I need to go back to this and see the equation. 2 okay, cos 2x sin 2x and then 5 they used. I don't know how. 1 minute. I think they're going to use some variations of the previous question. For example, instead of writing sine square cos square, I can write down the derivation, which is 1 minus 2 sin a over 2, 1 plus cos 2a over 2, those variations. So 2 sine square was actually 1 minus cos 2x divided by 2. Then this one 7 cos sine x cos x. Wait, no, for sine x cos x, yeah, actually this will be like positive sine x cos x. I think I'm at this point just trusting the process. I think this will give me the total work, like prove the entire equation like the way it was stated in the question. So this is going to be cos 2x minus 1 over 2 again. If I'm not wrong, let me go back and see if it was correct or not. Right, cos 2x plus 1 it was, right? 2x plus 1, 1 minus cos 2x, right? Sorry, this was plus over here. Okay, in that case, these things get cancelled out. Now you're left out with what? 1 minus cos 2x plus 7 sin x cos x, and over here you're going to get 3 cos 2x by 2 and then half. Okay, in that case 1 plus half is 3 by half again, 3 by 2. Then this one is minus 1, this one is positive 1.5 cos 2x. So eventually this one will also give you this cos 2x and 7 sin x cos 2x. This one will actually be 3. Sorry, I made a mistake. This is going to be 3 because 3 was multiplied with everything inside the bracket, right? So 3 gets multiplied with 3 cos 2x, 3 gets multiplied with 1, so 3 over 2. So then 3 over 2 plus 1 will give you 5 over 2, not just 3 over 2, 5 over 2. From this part, if you take half common from this equation entirely, if you take half common, this is going to be cos 2x plus, if you're taking half common, then it will be wait, again one thing, cos x sin x, right? 7 cos x sin x. Yeah, this can be written as wait 1 minute. I think for part A we did some working. No, not for this question. I think for the previous question we did some working that cos x sin x, right, cos x sin x can be written as 2 sin a. Right? This one also was in the next question that over there you had, I'm going to introduce this over here in this part of the equation, 7 2 sine 2x. Now this is going to be over here 14 sine 2x, 14 sine 2x, which is eventually going to be what? 14 divided by 2 will eventually be 7. So 7 sine 2x plus 5. Right, this was exactly in the format in a question was asking you to keep your answer in. So this is it. Now problem is I didn't actually kept much spaces for this trigonometric equation, but they need a lot space. This is for part B. We completely clearly proved that, but for part C again, where you have to find out the value for some things, like they have given you that equation again and you need to solve that for dy by dx equals to 0, and the angles should be in within the range of 0 to 180 in whole numbers. For this part, I actually don't have much space in the previous questions part also. Yeah, these spaces are also used. Yeah, this one is unused. Okay, this is from that question. What question was it? 1 minute. This is from May 2023 1P question C. Okay, so we are using this space for trigonometry. May 23 1P question 9C. Okay, for question 9C it was already given 2 sin x minus cos x sin x minus 3 cos x, and then again the value for y we simplified it, right? We got cos 2x over 2, I'm not taking half common over here, minus 7 over wait, yeah, this one actually becomes 7 over 2 sine 2x and then again 5 over 2, right? This was the expression. Now I have to dy by dx this. If I dy by dx this becomes negative sine, no, the cos integration will give you a positive sign, sorry. This will give you sine 2x divided by, it was already divided by 2, right? So now this will give you 1 minute. Oh, we are integrating it, right? Sorry, made a mistake. For integration, for differentiation now, this is going to be negative 2 sine 2x divided by 2, and then again over here we're going to get 2 7 over 2 cos 2x. This will be entirely 0. Obviously this 2 gets cancelled out and it was equals to 0, right? So you are going to get sine 2x negative sine 2x minus 7 cos 2x equals to 0. At the end, take everything to the, take that cos 2x to the right hand side. Sine 2x 7 cos 2x, this is going to be minus sine 2x over tan, cos 2x equals to 7. So basically you are going to get tan 2x equals to minus 7. Right, so if the value for tan 2x is minus 7, 2x will be tan inverse minus 7. This was in the, the range over here was in terms of angle. So you also have to calculate this in terms of angle. So tan inverse minus 7x gives you minus 81 over 9. So the value for 2x, this is the calculated value. This is negative 81 over 9 degrees. And this is the first value. For the second value, it will be 180. It was tan, so 180 plus first value, but the first value itself is negative. So it will be negative 81.9. And then again for the next part, this is going to be negative third value it was 360 plus first value, but then again it will be negative, so 360 minus 81.9. now these are the values for 2x, not just x. Okay, this is going to be this. Minus 180 gives you 98.13, and then next one gives you 278.13. and then again, in order to find out the value for x, divide all the data by 2. 98.13 by 2, 278.13 by 2. At the end, you are going to get, this one will be entirely 0 because our range was from 0 to 180. This is going to be negative. The next one is going to be 49 degree, and the other one will be 139 degree approximately, because we are supposed to keep our answers in integer numbers. So this is the value for x, 49 and 139 only. So this is the working for part C. I hope it was clear for all of you. We'll move on to the next question. I think after this we have one other question left for trigonometry. Trigonometric equations. These are quite lengthy maths, I can see. But we had a space over here also. So I will just cut this, and we'll try to keep it as close to your answer. Wait 1 minute. Let's see if you have any space after that. No, I do not have any space. Okay, this is it for your trigonometric equation for that part. We will now move on to your last question of trigonometry. This one. Show that cos A minus B minus cos A plus B is sine 2A sine B. Okay. Okay. For part A, cos A minus B minus cos A plus B. Over here, this is going to be cos A cos B plus sine A sine B. And this one would be cos A cos B minus sine A sine B. This one is going to be what? At the end, if you remove the brackets, right, we can clearly see this is cos A cos B plus sine A sine B minus cos A cos B plus sine A sine B. I can clearly see these cos components get cancelled out entirely. So you're left out with 1 sine A sine B, 1 sine A sine B. So obviously this is 2 sine A sine B. And then again after this you have to show that cos 5 theta minus cos 9 theta is equals to cos sine 7 theta 2 theta. Okay. I mean, I can clearly see that there are similarities. Cos 7 theta minus cos 9 theta. I can break down cos 7 theta 9 theta as cos 9 theta minus 2 theta. Yeah, right, that is 7 theta, and then again cos 7 theta minus 2 theta, right? Right, 7 theta. So it was 5 theta. Okay, sorry. 5, in that case again we have to use 7, right? 5 theta. So over here is 7 theta minus 2 and 7 plus 2. So similar concept, you have to use cos 7 theta cos 2 theta. This will be positive sine 7 theta cos 2 theta, and then again cos 7 theta cos 2 theta minus sine 7 theta cos sine 2 theta. Obviously this entire things will be cancelled out. We're going to be left out with 2 sine 7 theta sine 2 theta. So this is it for your entire working. After that, then they have stated that solve this equation that cos 5 theta cos 9 theta is equivalent to root 3 sine theta 7 theta, and your answer should be in terms of pi within the range of 0 to 1/3 pi. Okay. For part C now, cos 5 theta minus cos 9 theta equivalent to 5 root 5 or root 3? Root 3, sorry. Root 3 sine 7 theta. I already know I can write this as 2 sine 7 theta sine 2 theta root 3 sine 7 theta. From both the equations, this sine 7 theta will be cancelled out, and will be left out with sine 2 theta root 3 over 2. Eventually 2 theta would be sine inverse root 3 over 2. From this part again, I will have to shift my calculator to radians mode. So sine inverse root 3 over 2, this one turns out to be pi by 3. Over here your range was within 0x pi by 3, right? The value over here you're calculating is coming out to be pi by 3, but that's not a problem because this is a value for 2 theta. You'll eventually have to divide 2 with the original theta again, right? So this is your first value that you're getting, pi by 3. For the second value, this is going to be pi minus pi by 3. And then again, let's just calculate for the third value also, just to be sure that we're calculating all the value. That would be 2 pi plus pi by 3. Okay, other than that, no need to calculate any more data for it. So in that case, theta will now be pi by 3 over 2. This one will be what? 2 minus 1. Sorry, 3. Yeah, this is going to be 2 pi by 3 by 2. And then again, this is going to be 6 minus 1. So 5 pi by 3 over 2, which is now going to be pi by 6. 2 pi by 6. Yeah, this one again turns out to be 1 pi over 3, right? And then again, this one turns out to be 5 pi over 6. Now, you just have to understand that obviously this values for pi by 3, I mean, this one would be greater than your final range, right? So the only values that you're going to accept is pi by 6 and pi by 3. This is way too big, so we're not going to accept that for your final answer because range was greater than equal to or less than equal to 1/3 pi. So this is your solution for part C. For part C is done. After that again, you have to integrate this equation within the range of pi by, I think this is 7. Yeah, 7 and 0. Okay, now you have 8 sine 7x cos 2x and then tan 2x. Okay, pi by 7. I mean, the same format, you just have to integrate, do your own working to solve these maths every time. So pi by 7, 0. You have the formula was, I think, 8 sine 7x cos 2x and tan 2x, right? It can be broken down as sine 2x over cos 2x. So sine 2x over cos 2x, which clearly makes it clear that this 2 will be cancelled out and you are left out with 8 sine 7x sine 2x, right? And then again you can break this down further. That is, you can take 4 common and then it will be 2 sine 7x sine 2x. This is exactly in the format of 2 sine theta, 2 sine 7 theta sine 2 theta, right? Which was actually written in format of 4 cos 5x minus cos 9x. If you guys remember from part B1, from part B over there. Obviously all of the terms, they are going to integrate it within the range of pi by 7 and 0, pi by 7 and 0 with respect to dx, dx, dx. Now we'll start the integration. Obviously 4 over here cannot be integrated, so I'll just take 4 out of the integration sign, and when you integrate 5 cos 5 theta, it becomes cos 5 theta, right? Cos is positive, cos will remain positive, so sine 5 theta, 5x over 5, and then sine 9x over 9, and within the boundaries of 4 pi by 7 and 0. After this, we'll have to input pi and then subtract it with 0 because the lower boundary was 0. So obviously everything is multiplied over here. So sine 5 pi over 7 over 5 sine 9 pi over 7 over 4, and this entire thing is 0. At the end, when you multiply this thing with the 4 on the outside, you're going to get your value as 0.973 as your final answer. So this is the integration part for trigonometry, and this is how we are going to calculate trigonometric equations in all the cases. Okay, so I hope these questions were clear enough to clear some concepts of trigonometric equations. We'll now move on to the next topic, which is mensuration over here. Okay, for mensuration, basically they are going to use simple structures, usually pyramid or cone, or this is cylinder, rectangle, right? These are the structures they are going to use for mensurations over here. So for example, for this mensuration, this is from Jan 22 paper 1, we can see a structure, right? Over here it says the design of a flag consisting of a white cross on a grey background, where it is stated that AEFG, this one, AEFG, FG and DLMN are squares, DLMN are squares with sides 3x, and BQ, BPQR, BPQR and your CTUV, they are rectangles with sides 5x and 3x, and width of the cross is y. This one, this NV is y, and the total area of the flag is h. Write down an expression in terms of x and y for each. The total area of the flag over here, right? That is what? Length into breadth, we can understand this is what? 3x and y, and this is 5x, 3x and y. So length over here is going to be 6x plus y. Length is 3x plus 3x plus y. This is going to be 6x plus y, and the breadth over here is going to be 5x plus 3x plus y, which is going to be 8x plus y. Right, for area, we're just going to multiply the length into breadth, because eventually this flag is a rectangular shape, right? So length into breadth will give you the value for your total area. We're just going to write this over here. This is your length and breadth, and area would be length into breadth, that is 6x plus y and 8x plus y. You can simplify it if you want to. This is going to be, if you simplify it, this is going to be 48x square plus 14xy plus y square. So this is part A. In part B, it says that given that the area of the cross is k, so that k is this much. Okay, we can find out the value for k. For the cross only, I just have to subtract the areas for AEFG and BPQR from the total area. Now I already know that AEFG and DLMN, they are squares, right? So AEFG and DLMN, they are both going to have areas of 3x whole square, that is going to be 9x square, and then again area for BPQR is equals to CTUV. They are both again going to have same formula, length into breadth, which is going to be 5x multiplied with 3x, which is now going to be 15x square. So at the end there were like 4 areas of this much, right? Okay, let's just do this over here. Okay, now there were 4 areas of this much, or total area. In order to find out the area for cross, it is going to be, total was 48x square, 14xy plus y square. This will be subtracted with 2 9x square and 2 15x square. which is going to be 48x square plus 14xy plus y square. This is 18x square and 30x square, which is obviously 40x square, which we can understand. So they will be cancelled out together, and at the end you are going to have 14xy plus y square, and this was equivalent to k, right? We proved this clearly. This was for part B only. After this, again we'll move on to the total area of the flag is 3432, and the area of the cross is 1080. Now find the value for x and y. This is simultaneous equation at this point, right? The total area was 3432. Okay, for part C now, area is 3432, where the expression was 48x square plus 14xy plus y square is equals to 3438. And now we know that k, or 14xy plus y square, 14xy plus y square is 1080. I can easily eliminate the two equations together, right? I can easily eliminate the two equations together. That would make this entire thing cancelled out, and now you will have, no, elimination actually makes your, no, elimination actually works, right? So 48x square, as you had 0x square over here, right? So 48 minus 0 is still going to be 48, and this over here also going to be negative. So 34, 30, I don't think it was 38, right? Yeah, it was 32, made a mistake. 34, 32 divide, must be minus 1080. This will give you 2352. So the value for x would be 2352 over 48, everything under a square. This one gives you 7. So the value for x is 7. If x is 7, you can easily calculate y. Y in that case would be, I'll substitute this into the second equation. 14xy plus y square is equals to 1080. This was your second equation. I didn't wrote it over here, but this is your second equation. Okay, now for this case I already have the value for 7, which makes it y square. 14 into 7 gives you 98y, and 1080 equals to 0. So over here also, if you do middle term from this part, the value for y would be actually 10. So y, I mean, it also gives you negative, but we're only going to accept the positive value because length, y was representing length, and length can never be negative. So this is the case. Obviously do the middle term. I am skipping middle term in some cases, but you should always do the middle term. Okay, without middle term they might cut your marks for this part. Okay, this is it for the first mensuration. After this they have a second mensuration from the similar paper, I think. And now it says figure 2 shows a rectangle ABCD where AB is 10 and AD is 15. E is the point inside the rectangle such that your DE is 13 and the angle BAE is 35 degree, given that AED, this angle is obtuse angle, that means greater than 90 degree. Find the area of the shaded place to one decimal place BCE. Okay. BCE, right? I mean, I already know that this one will be 15 centimeters. Yes, and after that I don't have any knowledge on how to procedure this. 1 minute. I have this angle over here, right? That means it will be used in some case. Other two sides are also not provided. no, I don't have that angle also. It is already given that this will be greater than 90. Oh, I can calculate this angle because one corner of a rectangle will always have 90 degree. So DAE turns out to be, angle DAE is going to be 90 degree minus 35 degree, which is 90 minus 35, 55 degree. Okay, now from that part I can use cosine rule to calculate the value for your angle E. Yeah, I can use cosine rule to calculate the value for your angle E. So in that case, sine angle E over there divided by 15 equals to sine your 55 degree divided by 13. On opposite of 55 you had 13 centimeter. So now for this angle E, this is going to be sine inverse. Inside this function you have 15 sine 55 divided by 13, which is going to be sine inverse 15 into sine 55 divided by 13. That is, this was actually in radian. 1 minute. Over here again you have to shift your calculator back into degrees, by the way. Sine 55 divided by 13. This gives you 70.9 degree, but then again it was already stated that this angle AEC was actually an obtuse angle, so 70.9 degree will not be accepted. We have to find out the second angle, which is 180 minus 70.9 degree. This is 109.1 degree, so 70.9 degree, 109.1 degree. We're only going to accept this one. Okay, now yeah, this is it, 109.1 degree. After this, now we have the angle, but using the angle we can find out or calculate the length of this AE side. Yes, we can find the length for AE, but we have to first find out this angle ADE. So angle ADE is basically what? Sum of a triangle. 180 minus 55 minus 109.1. This will give you the value for angle ADE to be 15.9 degree. And then again, using this you can use the cosine rule to get the value for AE, length for AE. Length for AE would be 15 square plus 13 square minus 2, 15, 13 cos 15.9, everything under a root. And again after this, if we calculate this, the length for AE turns out to be 1 minute, root over 15 square plus 13 square minus 2, 15, 13 cos 15.9. This one gives you 4.35 centimeters. Okay, so for this 4.35 centimeters again, AE is given. Using the length for AE, now you can calculate the value for these theta. Okay, so now using the length of AE, we can find out the value for angle ABE. So for angle ABE, we are again going to use sine rule, right? I'm actually using the fast format of sine rule, so I'm not going to write the equation. Sine B divided by AE, which was 4.35, I think. 4.35 is equals to sine 35 over 10. This is going to be 4.35 with sine 35, sine 35 divided by 10. This expression gives you sine inverse 4.35 into sine 35 divided by 10, and this one is 14.4 degree. Now from this part, as you have 14.4 degree over here, with this angle you can calculate the length for your EB also, that is also needed. For EB, then you can use your yeah, then you can still use your cosine rule. For this point actually, we're trying to find out angle EB, right? So opposite of EB is sine 35. Wait 1 minute. For ABE, I used, oh no, sorry, I made a mistake. For ABE, I cannot use that. For ABE, no, I cannot use that. For I have the lengths for AE and AB available. No, I cannot use it, but 1 minute, there's some other way around of this. Obviously I have the length for AE using AE and AB. I can calculate the area for this ABE triangle, but that will not help with my shaded angle. In that case, we can do one thing. 1 minute. Right, we can find out the value, but the theta over here for angle AEB, right? Yeah, we did. No, we cannot, because sine 35 doesn't have its opposite angle. And this angle is also not known, so we cannot calculate that either. Sorry, this point over here, we can consider that as H, point EH. Okay, EH is obviously creating a right angle over here. For this right angle now, we can write what, opposite, adjacent, right? So we have sine 15.9 degree. This was 15.9 degree. This is equivalent to, opposite was EH divided by 13. For this EH now, you have 13 multiplied with sine 15.9 degrees. So okay, this is your expression for this much. If this is given, let's consider this as x. Then EX is also the height of this shaded triangle, and base is already given, CB is 15. So in that sense again, now we can find out the length for this CX, which is going to be either 10 minus this 13 sine 15.9 degree. EX is going to be 10 minus 13 sine 15.9 degree, because the total length over here was 10, right? So this is going to be EX. After that, if the base is now given, height is given, base is given, we can easily calculate the value for your triangle BEC, which is half. Base was 15, height is this 13 sine 15.9 degree. If we calculate that, the final answer would be 48.2 centimeter square, right? This is the entire process of your working. As this was the last part of your calculation, we will do this, we'll take this to the very bottom over here, right? This is the last part of your calculation in this section. Now we're going to end this video over here, and thank you for watching this video. If you're going to watch this for the next again 3.5 hours, so yeah, this is it, and yeah, that's it. I'll stop the video over here. Thank you for watching. Bye bye. All the best for your exams tomorrow.